Hello students, once again I have come here, okay, not to teach you people physics, ashtu nightmare kodalla bidi. So students, hello. So science exam ಗೆ biology ಮಾತ್ರ ಅಲ್ಲ, physics ಇದೆ, chemistry ಇದೆ. So ಇವತ್ತೊಂದು physics marathon ಇತ್ತು. So for that we thought, why don't we introduce the actual physics teacher who's been teaching for KCET and who's right now at IISc. So we thought we will introduce her to you. Okay, so physics class will happen depending on the high weightage chapters, alva sir? So depending on ಯಾವ ಚಾಪ್ಟರ್ ನಿಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಾರ್ಕ್ ಕೊಡುತ್ತೆ ಇನ್ ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್, ಆ ಚಾಪ್ಟರ್ಸ್ ಮ್ಯಾಮ್ ಇವತ್ತು ಪ್ರಾಬ್ಲಮ್ಸು ಆಮೇಲೆ ಥಿಯರಿ ಫಾರ್ಮುಲಾ ಎಲ್ಲ ರಿವಿಷನ್ ಶೀಟ್ ಕೊಡ್ತಾರೆ, ಅದಾದ್ಮೇಲೆ ಪ್ರಾಕ್ಟೀಸು ಮಾಡ್ತಾರೆ. ಓಕೆನಾ
ಸ್ಟೂಡೆಂಟ್ಸ್? ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ಬಯಾಲಜಿ ನೋಟ್ಸ್ ನಾವು ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕಳಿಸ್ತೀವಿ, ರೈಟ್?
ಡೌನ್ಲೋಡ್ ಆಗೋ ಟೈಮ್
ತುಂಬಾ ದೊಡ್ಡ ಫೈಲ್ ಅಲ್ಲ, ಡೌನ್ಲೋಡ್ ಮಾಡಿದ್ಮೇಲೆ ಕಳಿಸ್ತೀವಿ. ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದ ಬಯಾಲಜಿ ನೋಟ್ಸ್. ಈಗ ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸ್ ನ ಕಲ್ತ್ಕೊಳ್ಳಿ, ಫಿಸಿಕ್ಸ್ ನ ಕಲ್ತ್ಕೊಳ್ಳಿ ಮ್ಯಾಮ್. Ma'am, just introduce yourself.
Yes, students. My name is Catherine, and today I will be teaching you physics. So we'll look at the most important portions. We'll solve problems, and I think by the end of the session, you will be able to do well in your physics exam.
ಸೊ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇನ್ನೊಂದು ಮಾತು ಹೇಳ್ತೀನಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಮ್ಯಾಮ್ಗೆ ಕನ್ನಡ ಅಷ್ಟೊಂದು ಕನ್ನಡಕ್ಕೆ ಬರಲ್ಲ, ಮ್ಯಾಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, ಬಟ್ ಮ್ಯಾಮ್ಗೆ ಮಾತಾಡೋಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸರಿನಾ? ಡೋಂಟ್ ವರಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ನಾನು ಮ್ಯಾಮ್ಗೆ ಹೇಳ್ಕೊಡ್ತಾ ಇದೀನಿ. ಹಿಂಗೆ ಗೋಪಿಕಾ ಮ್ಯಾಮ್ ಟ್ರೈನ್ ಮಾಡಿದೀನಲ್ಲ, ಆ ಥರ ನಾನು ಟ್ಯೂಷನ್ ಬಂದಿದ್ದೆ, ಟ್ಯೂಷನ್ ಆ ಥರನೇ. ಸ್ಟೂಡೆಂಟ್ಸ್, ಸೊ ಡೋಂಟ್ ವರಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಮ್ಯಾಮ್ಗೆ ಕನ್ನಡ ಅರ್ಥ ಆಗುತ್ತೆ, ಬಟ್ ಮ್ಯಾಮ್ ಮಾತಾಡೋಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಮ್ಯಾಮ್ ಮೋಸ್ಟ್ಲಿ ಇಂಗ್ಲೀಷಲ್ಲಿ ಇರ್ತಾರೆ. ಸೊ ಮ್ಯಾಮ್ ಯೂಶಲಿ ಇಂಗ್ಲೀಷಲ್ಲಿ ಹೇಳ್ಕೊಡ್ತಾರೆ. ಸೊ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಮ್ಯಾಮ್ ಪ್ಯೂರ್ ಪ್ರಾಪರ್ ಆಗಿ ಹೇಳ್ಕೊಡ್ತಾರೆ, ತುಂಬಾ ಸ್ಪೀಡ್ ಆಗಿ ಹೇಳ್ಕೊಡ್ತಾರೆ. ಸೊ ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ಸ್ ಕಮೆಂಟ್ ಅಲ್ಲಿ ತಿಳಿಸಿ, ಮ್ಯಾಮ್ ವಿಲ್ ಟೇಕ್ ಅಪ್ ದಟ್ ಕಮೆಂಟ್ ಡೌಟ್ಸ್ ಆಲ್ಸೋ. ಸರಿನಾ ಮ್ಯಾಮ್? ಏನು ಹೇಳ್ತೀರಾ?
ಸೊ ಸ್ಟೂಡೆಂಟ್ಸ್, ಲ್ಯಾಂಗ್ವೇಜ್ ಸಪ್ರೇಟ್ ಆಗಿ ಇಟ್ಕೊಂಡು ಕಾನ್ಸೆಪ್ಟ್ ಹೆಂಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ತೀರಾ ಅದೇ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರೋದು ಅಲ್ವಾ? ಇಂಗ್ಲೀಷ್ ಆದರೂ ಕನ್ನಡ ಆದರೂ ಕಾನ್ಸೆಪ್ಟ್ ಚೆನ್ನಾಗಿ ಹೇಳ್ಕೊಡ್ಬೇಕು ಟೀಚರ್ಸು. ಸೊ ಅದು ಕ್ಯಾಥರಿನ್ ಮ್ಯಾಮ್ ಮಾಡ್ತಾರೆ. ಸೊ ಅದಕ್ಕೆ ಅದು ಅಲ್ಲ ಮ್ಯಾಮ್, ಕೇರಳ ಪ್ಯೂರ್ ಕೇರಳ ಬೇಸ್ಡ್, ನಂತರ ಹೈಬ್ರಿಡ್ ಅಲ್ಲ ಮ್ಯಾಮ್, ಪ್ಯೂರ್ ಕೇರಳ ಬೇಸ್ಡ್. ಇವಾಗ ಒಂದು 2 years ಇಂದ ಇಲ್ಲಿದ್ದಾರೆ. ಸೊ ಹೌ ಮಚ್ ಶಿ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಶಿ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಬಟ್ ಶಿ ವಿಲ್ ನಾಟ್ ಬಿ ಏಬಲ್ ಟು ಟಾಕ್ ಫ್ಲೂಯೆಂಟ್ಲಿ. ಓಕೆ, ಸೊ ಐ ವಾಂಟ್ ಆಲ್ ಆಫ್ ಯು ಟು ಬಿ ವೆರಿ ಸ್ವೀಟ್ ಅಂಡ್ ಕೈಂಡ್.
ಯಾರು ಬಂದು ಪಾಪ ಮ್ಯಾಮ್ ಕಷ್ಟ ಕೊಡ್ಬೇಡಿ ಮ್ಯಾಮ್ಗೆ, ಸರಿನಾ? ಸೊ ಮ್ಯಾಮ್ ಹೇಳ್ಕೊಡ್ತಾರೆ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, ಡೌಟ್ ಇದ್ರೆ ಹೇಳಿ, ಸರಿನಾ ಸ್ಟೂಡೆಂಟ್ಸ್? ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಮ್ಯಾಮ್. ವಿ ವಿಲ್ ಲೆಟ್ ಮ್ಯಾಮ್ ಸ್ಟಾರ್ಟ್.
Yes, thank you.
Ma'am, you can connect. Yeah, just keep it that in the pocket. Okay.
Yes. Hello.
Do you want it now?
Now can you hear me?
Sound ಬರ್ತಿದೆಯಾ? ಅದೇ take some time. Lag is there. Students, sound ಬರ್ತಿದೆಯಾ? ಬೇಗ ಹೇಳಿ. sound check students, ಬೇಗ ಹೇಳಿ. ವಾಯ್ಸ್ ಬರ್ತಾ ಇದೆಯಾ? ಬೇಗ ಹೇಳಿ. ಬರ್ತಾ ಇದೆಯಾ? Yes. ಬೇಗ.
Yes. No sound. Hello.
Sound check. ಬರ್ತೇವೆ. It's fine, ma'am.
Okay.
Yes. Voice isn't video.
Okay, can you all hear me now? Yes. Okay, so let's start with electricity. So since you were not able to hear me earlier, I'll repeat what I said. Today we are going to look at the most high weighted chapters. So I've looked at all your previous papers, and I've looked at your model papers, and these 3 chapters that we are going to discuss today are the most important chapters. Okay, so we will start with electricity. So before we start with electricity, you need to know what an atom is. An atom has protons. So if you take an atom, it has protons, neutrons and electrons around it. Protons and neutrons in the nucleus, electrons around it. But these protons and neutrons cannot move. The only charge that can move is the electron outside. It can be free, it can move, how it moves and all that you might have learned in chemistry. So it can move freely. So this is utilized as electricity. So electricity is basically the movement of electrons. Okay. Now what is an electron? An electron is a charge. It has a negative charge. A proton also has a charge, but here we are going to talk about electrons only. So an electron has a charge. So that is the first thing that we are going to learn today. What is charge? So charge is the fundamental particle of matter. It can be positive or negative, it can be a proton or an electron, but let's forget about protons. In this chapter we look at only electrons. Now the basic unit of charge is coulomb, which is C. Now when I say the charge of this particular thing is 1 coulomb, what do I mean? What I mean is, if I have something, okay, and I say the charge of this is 1 coulomb, what I actually mean is, inside this I have so many electrons and the number of electrons is 6 into 10 raised to 8 electrons. So when you say, so when someone tells you the charge of this thing is 1 coulomb, it means it has 6 into 10 raised to 8. So imagine how big it is, 6 and 8 zeros, that many number of electrons. Now let's find out the charge of 1 electron. If this is 1 coulomb, yeah, so the charge of 1 electron would be 1 coulomb divided by 6 into 10 raised to 8. This would be 6 into 10, sorry, 1.6 into 10 raised to minus 19 coulombs. Okay. So this is the charge of 1 electron. 1 coulomb is the charge of how many electrons? 6 into 10 raised to 18 electrons. Apologies for that, 6 into 10 raised to 18 electrons. Okay. Is this clear? Let's move on. If it's clear, can you all give me some fire emojis in the chat? So we can move on to the next topic. This is charge. Next is electric current. So as I said, what is current? Current is the movement of charges. So this charge we have, which is an electron, if you have a wire, this electron will start moving. If you have 100 electrons, all of these 100 electrons will move. So this is basically the flow of charge, and I don't call it flow of charge, I will call it electricity. So electricity is basically the flow of charge. Yeah. So it can be defined as the flow of charge in a particular amount of time. Say I say 2 seconds. Okay. So in 2 seconds, how many charges will flow? That will give me the electricity at that particular point. So it is basically charge by time. Now charge is represented by the alphabet Q, time is represented by the alphabet T. So Q by T is equal to I, which is the alphabet that represents current. So what is current? Current is the amount of charge. What is charge? Electrons. So the number of electrons passing through a wire in a particular amount of time. Now we all know the unit of charge, the unit of current is amps, right? The unit of current is amps. See, for length you have meter, you have kilometer, you have centimeter. Just like that, for current also there are so many units. So amps is the standard unit, but other than amps you have milliampere. Okay, you have milliampere and you have microampere. So milliampere is basically 1 ampere divided by 1000 will give you milliamps. Now if you divide it, 1 divided by 1, 2, 3, 4, 5, 6 will give you microamps. So obviously both of these are smaller than amps. So amps is the biggest, milliamps is smaller, microamps is even more smaller. Is this much clear? Again, if it's clear, can you all put thumbs up in the chat so we can move on to the next topic? Some thumbs up please so we can move on. Okay, now we will do a simple question using the formula we learned. So a current of 5 amp is drawn by a filament of an electric bulb for 20 minutes. So what is current? I already mentioned current is the amount of charge flowing through something in a certain amount of time. So the amount of charge here is what you have to find out. That is what you have to find out. The current is given to you. So we learned the formula I is equal to Q by T. So Q is equal to I times T, and I is 5 times. Now, just like I said, everything has different units, but whenever you do problems, you should always use standard units. Ampere is the standard unit for current, so that is correct, you don't have to convert it, but the standard unit for time is seconds, okay. So you have to convert 20 minutes to seconds. So let me just do that. 20 minutes is 20 into 60 seconds, which is 120 seconds. So 5 into 120. Quickly tell me the answer in the chat. Quickly students, tell me how much it would be. Yes, can I know the answer please? Can you all quickly give me the answer? Yes, students. Are you all getting the answer? Yes. Yes, Avita, Manvi, Shivani, Manoj. Yes, good. It is 600. And what would the unit be? Very important for your exams. If you don't write unit, you will lose 1 mark. Whenever you do a problem, you should write unit. 600 coulomb. Okay? Yes. Yes, Dhruv, it's 600. Electromagnet, all that we will look in this class. You just have to stay with me, we will learn all that. Next is ammeter. So what is an ammeter? This is the symbol for an ammeter, and an ammeter is something that is used to measure the amount of current passing through something. So it measures electric current in a circuit. Now an ammeter is used to measure electric current, okay. So it will always have a low resistance. Now what is resistance? Resistance is the opposition to the flow of current. See, the word resistance means you are resisting, you are stopping. So what is resistance? Resistance is when current comes, resistance stops. So when huge current comes, if the resistance is also huge, it will not allow this current to pass through. Okay, so resistance is basically opposing the current coming. So an ammeter is used to measure current. So if you have high resistance, then the current will not reach the ammeter. So if this is the ammeter, okay, current is coming in like this. Now if there is resistance, the current will be blocked here. But only if the current reaches the ammeter, you can measure it. So we will have something with very low resistance. Since the resistance is very low, what happens? All of the current will reach the ammeter. Okay? What happened? Why do I have to adjust the camera? Someone's telling me. Okay, so since it's low resistance, it can measure all the current passing through it. Next, we will look at some circuit symbols. Oh, yes, students, this is 1200. Yes, yes. I've made a small writing mistake. This is 1200. So there will be one more 0 here. Okay? Yeah. Now we will look at some circuit symbols. So in this chapter, we will be, yes. It is 1200, yes. In my mind, it was 1200, but when I wrote it as 120. I'm sorry for that. So, circuit symbols. So, in this chapter, we will not be drawing, for a battery, you won't draw a box with all of those and all that. We will use circuit symbols. So, the symbol for a battery is a line, a straight line, a small line. So the big line represents positive, the small line represents negative. Now if you have two batteries coming together, it becomes, sorry, if you have two cells, this is a cell, if you have two cells coming together, it becomes a battery. So this is the circuit symbol for a battery, you have three cells here. And then a switch or a key is represented by this two brackets. Now if I put a dot in front, it becomes a closed switch. A closed switch and an open switch. This is a wire joint. So if you have three wires coming together and they join, this will be the symbol. Okay. Then what else? Now this means that this, hey, what happened? This wire and this wire are not connected. So if this and this, if I draw it like this, all the wires are connected. But if I put this, that means the first wire and the second wire, they are not connected from between. So that is what this means. This means wire crossing without joining. Okay. Now a bulb, see, it's always difficult to draw a full bulb like this. So for a bulb, you can just draw it like this. If you want to represent a resistor, you just have to do this zigzag. Now this is for a fixed resistor. For example, it will have only one value. So let's say the resistance is 10 ohms. So this will represent 10 ohms. If it's 50 ohms, this will represent 50 ohms. So this is for a fixed value of resistance. So it will have only one single value. But say I want 50, 60, 70, 80. Then what I have to do is I have to use another component which is a variable resistor, and that is represented by same symbol for resistance but with an arrow. There is also one more way of representing it. Again, same resistance but an arrow like this. So these are all different formulas for resistance. And then this I already discussed, ammeter and then voltmeter. Okay. So let's move on. You need these circuit symbols to understand circuits. That's why I have discussed the circuit symbols. Next is potential difference. So we looked at what current is. Current is the flow of charge. Now what is resistance? Resistance is the opposition to the flow of current. Now there is something else that you might all have heard. It is, yes, we will do all the important chapters, and if you have doubts you can just type the doubt in the chat. That's okay. Yeah. So one more thing that you might have all heard is voltage. You always keep saying, no, the voltage is down, there is no voltage. You keep saying that, people say that in your homes as well. So what is this voltage? So imagine I have a circuit. Okay. Yeah. Let's put a bulb here. Okay. So imagine I have a circuit. The circuit has a current I flowing. What is current I? It is basically the electrons passing through the circuit. But once an electron comes out from here, this electron has to reach back to the other terminal of the battery. Why doesn't it just stop in between? It always reaches back. So there is some force pushing it. See, imagine you have a water tank. Okay, this water tank is kept at a height and you have a pipe of water coming down. So this pipe of water coming down is electricity and this water tank is your battery. So what happens? As you increase the height, this water coming down will come down with more force. So this height is basically your voltage. So if you have a battery and you have current coming out of it, the more the voltage, the more the force by which the current will move. Okay. So that is what is potential difference. It is the work done to move one charge. One charge is one electron from one point to another. So only if the circuit has a good amount of voltage, the charges will move faster through it. Okay. What didn't you understand? Okay. So that is voltage. So what will be the formula for voltage? Work done by charge. Because it is the work done. It is how much work it's doing to move one charge from one point to another. Okay. It is the charge that moves. It is the work done to make the charge move through the whole circuit. So current is the movement of the charge. Potential is the work done to make the charge move. So current will not flow by itself, just like I mentioned the water tank. From the pipe, water will flow only because of the height. If it's kept at the ground, it's very difficult for water to flow. But if it's kept at a height, water can easily flow. So as you increase the voltage, current can easily flow. Okay. Let's move on to the next topic. So work done by charge. Note this down, that's the formula. Okay. Yes. Next is to measure current, you have an ammeter. Similar to that, to measure voltage, you have a voltmeter. But in ammeter, we learned that the resistance should be very low because current has to flow through it, only then you can measure it. But here, you have to measure voltage. So why do you want current to pass through it? So voltmeters will always have, where have I written? Yeah, high resistance. Why does it have high resistance? Because a voltmeter does not want current. Resistance is blocking current. But we don't want current, we want voltage. So we have to block all the current. That is why this will always have a high resistance. Okay. So a voltmeter is something that is used to measure voltage. It will always have a high resistance. So sometimes in you might get questions saying why would voltmeters need high resistance or what resistance should a voltmeter have. So you should know this. Voltmeter does not want current to pass through, so it will always have a high resistance. Okay, let's move on. And voltmeters are always connected in parallel. Ammeters are always connected in series, voltmeters are always connected in parallel. This also could be asked. Name how voltmeters are connected. Always in parallel. Ammeters are always in series. Okay, let's move on to the next question, next topic. Okay, this is a question. So you have to find out how much work is done in moving a charge of 10 coulomb across a potential difference of 9 volts. So V is 9 volts, Q is 10 coulomb. What do you have to find out? You have to find out work done. So we already learned here, we've already learned that voltage is work done by charge. Let's do that here. Voltage is work done by charge. So work done is charge into voltage. So whenever you have confusions on rearranging formulas, what you can do is you can put it inside a triangle. Okay. So the first thing is voltage, you put that on, no. So whatever is divided, you put that like this. Okay. So this line basically represents division. So W by Q is divided and then V is here. So from this you have W equals V into Q. Q is what? W by V. V is W by Q. This line represents division. This line represents multiplication. So if you have doubts there, you can just, in rearranging, you can just put it inside a triangle and do it. So let's do this. W equals Q into V. What is Q? 10 coulomb into 9. How much is it? Quickly. Ma'am, some josh. Yes, I will try to have some more josh. Yes, 90. Good, good. Who's that? Sarojini Elizabeth Vinay. Yes, it's 90. So the answer is going to be 90. What would the unit of work done be? It is same as the unit of energy. Oh, I have put the slide here. Okay. So let's look at one more question. One more question. A bulb is rated at 80 watt and the potential is 230 volts. Find the current drawn by it when it is connected to a 300 volt supply. So first it's given to you that the power is 80 watt and the voltage is 230 volts. So we have to find out how much resistance it will have. So have you learned this formula in your previous classes? You might not have, right? The power, okay? The power of something is basically the amount of current passing through it in a certain amount of voltage. So power is always V into I. Okay, so if I say the power of a, you might have seen, you know, the machines at home, they will always have a power rating. So if you say the power is 50 watts, okay, W is not for work done, W is the unit of power, watts, W-A-T-T. So when I say the power is this much, what I actually mean is the product of voltage and current is your power. But what else is given? Here I have to find out the current. So again, let me put this inside a triangle. So multiplied terms will go to the denominator, P will be up. So from this I have I is equal to P by V, which is this formula. Okay, let's do that. What are the terms? 80 watt and 230 volts. Substitute that here. 80 watts and 230 volts. So quickly find out the current. How much is it? Okay, so did you all find out the answer for here? Now the resistance, this will actually be P. Do one thing, for this question I will explain it once again after I teach you power, and this we will learn. We'll come back to this question, okay? I'll teach you one more concept and then we'll come back to this question. Yeah, after we learn Ohm's law, we'll go back to that question, then it will be a little more clear to you. So let's look at Ohm's law first, okay? Ohm's law is basically a law that tells you how current and voltage are related, okay? So if I have a wire, okay, a normal conducting wire. So on this wire, I have voltage passing through it, I have current passing through it. So how it is related is what is given by Ohm's. Ohm's law gives a relationship between current and it states that the potential difference, if I have a metallic wire, okay, the potential difference, which is the voltage across the end of the metallic wire, in any electrical circuit is proportional, the potential difference across the wire is proportional to the current flowing in it, given that the temperature is constant. Okay. So, the potential difference passing through a conductor is always proportional to the current, but the wire should not be heated or kept in a fridge or anything like that. It should always have the same temperature. Now, every time you have a symbol like this, to remove that symbol, you have to add an equal to and a constant. Okay. So, to remove proportionality, you always have to have an equal to and a constant. So, I will do the same here. I put an equal to and a constant, which is resistance. So, V is equal to I times R. Voltage is current times resistance. With this formula, we can do the previous question. I will come back to that. So, if I explain this, it will be a little more clear to you, that's why. So, V is equal to IR is the famous Ohm's law. So, you have to learn the law as it is. You can't alter the law, it's a law. Okay. R is resistance. R is resistance, V is voltage, I is current. Okay. So, for a particular conductor which has a certain amount of voltage and certain amount of current, the resistance will always be a constant. Yeah, Rocky Bai is saying this question came for 3 marks in preparatory exam. Yes. So, please pay attention, this question came for 3 marks. Thank you, Rocky Bai. Okay. Now, yeah, R is a constant for the given metallic wire. It's also called as resistance. Now, this is an experiment that you might have done in school. So, this experiment is how we found out Ohm's law. So, it's a very simple experiment. First, you put one battery. Okay, imagine these two are not there. You put one battery. To the battery, you have a switch. In order to open and close, you have to switch on and off. No? So, you put a switch there. And to the switch, I put a resistor. To find out the voltage, I already explained voltmeter should always be connected in parallel. So, that is why this is your voltmeter. And ammeter should always be connected in series. So, that is why this is your ammeter. I will put a different color, yellow. Ammeter, voltmeter. Okay. So, there is an ammeter, there is a voltmeter. This is all connected to one. First, it is connected to only one battery. So, when I switch on the battery, what happens? I will put a table, voltage, current. So, now I have one battery. So, I will get some value of voltage. I will just put it as A. Now, the voltmeter will give you one value of voltage, ammeter will give you one value of current. And then what I do? I will add one more battery. Now, I have two batteries. So, I have more voltage. So, I will get another value here and here. Then I add one more battery. So, I have again more voltage. I keep on adding batteries. I keep on getting different values for voltage and current. So, for each battery, you will get one value of voltage and current. See, I have only put one resistor. What is the symbol for? This is the symbol for fixed resistance. So, if this has a value of 5, it's always 5. If it is 10, it's always 10. It's not going to change. So, R is constant. Ohm's law states that R is constant. So, you cannot change R. Now, we have so many values of I and V. We will plot that on a graph. So, if you plot the first value here, second here, third here, fourth here. If you keep plotting the graphs, you will find out it becomes a straight line. Difference between resistance and resistor. There is no difference. Resistance is opposition of the flow of current. Resistor is a device that offers the resistance. Okay. So, a resistor will give you resistance. Resistor is the name of the device. Resistance is the name of the thing that it is opposing. Okay, Vinay, is it clear? Tanu, I love you. Okay, yeah. So, potential difference and current, you will always get a straight line graph. So this graph, any graph, ma'am, simple circuit will be asked in exam. Yes, we will discuss some simple circuits. So any graph that gives you a straight line like this means, the graph means direct proportionality, which means whatever is on the x-axis and the y-axis, they are directly proportional. When one is increasing, the other will also increase. So here voltage and current are directly proportional. So when one is increasing, the other will always increase. Okay? Yes. Guys, this is a physics class, okay? You are all proposing to other people here. So this is a circuit that's going to give you, voltage and current. It's also showing you the graph. So the only thing you're doing is you keep adding batteries. When you keep adding batteries, voltage will increase, current will also increase. If this is clear, can you all put some fire emojis? Stop talking to each other and listen in the class, students. Can you all put some fire emojis if this is clear? I don't want to know who you love, Harish. Okay, put some fire emoji so we can move on to the next question. Stop talking to each other. Yeah, so till now we've all looked at Priya Varshu, whose Insta do you want? Okay, so we are going to find out resistance. Okay, I mean, we have been discussing resistance, but the slide just came now. So resistance, now you all should know what is resistance without even looking at the slide. Resistance is the opposition of current and it is represented, I mean, it has the symbol, sorry, it has the unit ohm. See, just like length has meter, centimeter and all that, resistance is always ohm. So if I say the resistance of the wire is 5, I will say it is 5 ohm. If I say it's 25, you will say it as 25 ohm. Ohm is the unit of resistance. So it is a property of a conductor to resist the flow of charges. What is flow of charges? Electricity. So it is a property of a conductor to resist the flow of current. A potential difference across two of yeah, this is just a simple example saying we already know V is equal to IR. So if voltage is 1 and current is 1, the resistance will also be 1 ohm because R is equal to V into I. So 1 is equal to 1 into 1. So if voltage and current both are 1, the resistance will also be 1. So from this, you can know that current, okay, current and resistance, they are inversely proportional. For example, so V is equal to IR. Now R is equal to V by I. As I already mentioned, anytime you want to put a proportionality, you remove an equal to and a constant. So let's say voltage is constant. So I can say R is proportional to 1 by I, which means R and I are inversely proportional. So whenever R increases, I decreases. So if R is doubled, I becomes half. Okay? Yes. So this is resistance. Next we will look on what all factors resistance depends on. So the first thing that if this is a conductor, okay, so this is a small piece of a big wire. I have a wire through which electricity is passing. So I cut that wire, I take a small piece, okay. This piece is just to show you on what all factors the resistance changes. So the first thing is the length. So resistance changes with length. Next is the area of the wire, how thick the wire is or how thin the wire is. Resistance depends on area as well. And resistance also depends on the property or the type of the wire. So all that combined together, I will get this. Resistance is proportional to the length. Resistance is inversely proportional to the area. What does resistance proportional to length mean? As the length increases, the resistance increases. So if I have a wire that is 2 centimeters and I have another wire that is 5 centimeters, the 5 centimeter wire will have more resistance because it has to travel through a longer distance. So imagine if you are walking through a crowded street, okay. When you are walking through the crowded street, the more longer the street is, the more difficult it is for you to walk. Same thing, the more longer the wire, the more difficult it is for current to pass through. So that means it's because resistance is very high. So resistance and length is proportional, inversely proportional to area. Why? Imagine I have a wire which is of this size and I have a wire which is bigger. Through which one will current be easily able to flow? Through the bigger one. So whenever area is big, resistance is less because current can easily flow through it. That is why resistance and area are inversely proportional, because as area increases, it's easier for current to flow through it, which means what? It is inversely proportional. Now we'll combine these two. You have R is proportional to L by A. Again, as I said, to remove this proportionality, I put an equal to and a constant. This constant is called as resistivity. So R is equal to rho L by A. So this rho is resistivity, and resistivity is a property of the material. Yes, it is called the electrical resistivity. Okay, resistivity is called the property of a material. Okay, can you all quickly put some fire emojis if you understood this, so we can move on? What is cross section? Cross section is basically area. See, if this is a wire, this area of the wire is its cross section. Okay, so if it's a bigger wire, it will have a bigger cross section. The area of the wire, the space inside the wire is area of the wire. So if the space inside is more, current can easily flow. So resistance will be very less because current is flowing. What is resistance? Resistance is stopping the current. Okay, is that clear? Yes. Yes, we will solve problems. So before solving problems, we should know the concepts. So after that, we will solve problems. You will have questions from concepts also. This is not a competitive exam. This is your board exam. You will have questions from concepts also, not just problems. So resistivity is a characteristic property of the material. So if I have a particular wire, that wire will have some property of its own. That is its resistivity. It does not change for one particular wire. So if I have two wires and the two wires are made out of two different materials, they will have different resistivities. But if I have one wire and I cut it into two, they will both have the same resistivity, because resistivity is a property of the material of the wire. It does not change with length or area. It is just the property of a wire, how it is made of and how its electricity passing capability is and all that. So we looked at that, and the unit of resistivity is ohm meter. How did I get that? Let's do that. So R is equal to rho L by A. Now let's write all of these in terms of formulas. What is the formula? I mean, in terms of units. What is the unit for R? Ohm. Resistivity is unit, we don't know. The unit of length is meter. The unit of area is meter square. So meter and meter square would cancel. So what happens? This would cross multiply. So ohm meter will be the unit of resistivity. Okay, so that is how I get this unit, ohm meter. Is that clear? Yes. Can you all put some thumbs up if this is clear to you? Now, resistivity does not change with length or cross sectional area. As I mentioned, you have two wires. I mean, let's say you have this is one wire, okay? This has a resistivity of 5. I cut it into two. Both of these will have resistivity of 5. It does not depend on the length or the area. It only depends on the properties of the material, like what material it is made out of. If I cut it, the material does not change. But it changes with temperature. Because if I have this wire cut into two and I heat one, won't that change the properties of the material? That will maybe melt it or increase some things can change in between. It can change the atoms and all that. So with temperature, resistivity will change, because temperature can alter the material, but it will not change with length or area like resistance. Now if you have alloys, you will see the resistivity is about 10 raised to minus 8 to 10 raised to minus 16. But insulators have a very high resistivity. 10 raised to minus 8 means 0.000 something, very small. 10 raised to 12 means 1000 something, like more than 10 and 12 zeros. So that's why insulators cannot allow charges to pass through them. What is an insulator? Insulator is something like plastic. Can current pass through plastic? No. Your wooden tables. Your wooden tables are made out of wood. Wood cannot pass electricity. So all of those materials will have very high resistivity. So it will not allow current to pass through. So that is why you can see the resistivity is very high. But alloys are a mixture of so many different materials. You mix so many materials to get the best material. That's an alloy. So it will have very low resistivity, which means it's good for current to pass through. So yeah, so if you have, imagine you have 3 metals, okay, A, B, C. So you take all these 3, mix it, make an alloy. When you mix it, the resistivity of A, B, C individually will be less than the combined. So the purpose of mixing it is to reduce the resistivity and making it better suitable for conducting purpose, like making wires or anything related to electricity. Okay. Wood can pass electricity. Who said wood can pass electricity? Wood is an insulator. It cannot pass electricity. Yes, very good, Jayuri. Yes, if you have a material that conducts, you always cover it with an insulator so that you protect yourself. We will learn all that in today's class. How meter? The length, the unit of length is meters, the unit of area is meter square. Meter divided by meter square, I cut 1 meter, so 1 meter remains. This cross multiplied, it becomes ohm meter. Is that clear? Okay. Okay, Vinay, is it clear? Yes. Okay. So if it's clear, can you all give me some thumbs up so we can move on to the next topic? So did you understand the difference between resistance, resistivity, current, voltage, all of that? Because these are the basic concepts in this chapter. Resistance is opposition to the flow of current. Resistivity is a property of a material. It only changes with temperature. Okay, question. Okay, let's do this. How much current will an electric bulb draw from a 220 volt source? So this is voltage. The resistance of the bulb is 100. So this is R. How much current will an electric heater coil draw from? Again 220. So this is V and R. Okay. Let's do this. So it's a very simple question. V is 220, R is 1200. We will use Ohm's law. V is equal to IR. So putting it inside a triangle, the multiplied terms will be here and V will be on top. So what is I? V by R. V by R. So substitute, you will get 100. Quickly do it and tell me if you are getting 100. Quickly students, tell me if you are getting 100 ohms. Are you getting 100? Okay. So those who haven't seen the question, quickly take a screenshot of this question and you can solve it. It's a very simple question, direct question. You can take a screenshot. Yes. You can take a screenshot of this one also. Yes, Vinay is 2.2. Good. Who else? Nobody else solved it. Only Vinay. Others also quickly solve it. Maybe 0.1. How maybe 0.1? 220 by 100, it will be 2.2. Okay, now we will learn on what resistance is, what resistivity is. Now what we will do is we will combine resistors. Okay, so I can combine resistors in different ways. I can combine them in series and in parallel. So these are two ways I can combine resistors. So when I combine them in series, what happens? If I have the total resistance of the circuit, okay, let me not do that now. Let me tell you what series is first. So series is when the resistors are connected one after the other, like this. Parallel is when I have a battery, all the resistors are connected across one common point. Here these are all together connected to a battery. They are all connected one after the other, but here you can see they are all individually connected to the battery or whatever component is there on top. So that is parallel. Parallel is when each of these have an effect on the battery, but here the effect of the battery keeps reducing because it is all one after the other. Let us look at that in detail. So this is an example of a series circuit. You can see this R1, R2 and R3. These three are connected in series with respect to the battery. Now voltmeter is always connected in parallel. That is why the voltmeter is connected like this. So there are 3 voltmeters to measure the voltage of each of the resistances. Now we will look at the properties, the rule for finding resistance in series. Let's do it. First thing you need to know is how current and voltage flows in the circuit. Because what is resistance? Resistance is equal to V by I. So only if you know how current and voltage flows through it, you will know how much resistance flows through it. So first thing that you need to know in a series circuit is that the current is the same everywhere. So in this circuit, the current is I. Throughout the circuit, the current has only one value. So if the battery gives 10 amps, then the whole series circuit has 10 amps. It is not dividing or subtracting or multiplying anywhere. The current through a series circuit is the same everywhere. Okay. First point that you need to keep in your mind, the current through a series circuit is the same everywhere. Now what about voltage? Voltage will keep on changing. So the voltage here, so the voltage across R1 will be V1, the voltage across R2 will be V2, the voltage across R3 will be V3. The voltage will be changing. So if the battery is 9 volts, this 9 volts will be split between every component in the circuit. So if each resistor takes 3 volts, the next one will take the next 3, the next one will take the next 3, and that's over, voltage is finished. That's how voltage varies. It is divided between all the components in the circuit, but current is the same. So here also current is I only, here also current is I only, here also current is I only. Okay. Parallel and series advantages we will discuss after we discuss what is parallel and series. Okay, I will discuss all this, relax. Okay, you be with me in class, we will discuss all this. Now let's look at the formula. So the formula for resistance is Ohm's law. What is Ohm's law? V is equal to IR. So R is equal to V by I. Let's do it. So since current is the same, you will put current as I. Okay. So V1 is IR1, V2 is IR2, V3 is IR3. Why I everywhere? Current through a series circuit is not changing. Now let's add them. So if I add V1 plus V2 plus V3, what is it going to be? IR1, V2 is IR2 plus V3 is IR3. Now since I is the same for all, I will take I outside. What remains? R1 plus R2 plus R3. Now what is V1 plus V2 plus V3? It is V total. So this is V total. Now what is V by I? It is the total voltage divided by total current will be total resistance. So V total by I total will be R total. Okay. So if I take this and this, V by I, V total by I would be R total, which will be equal to R1 plus R2 plus R3. That is what is this. Okay, or this V total can be written as, what can it be written as? I times R total is equal to I into is equal to I into R1 plus R2 plus R3, which is equal to I and I cancels. You can do it this way also, you can do it the other way also. Is this clear? Galvanometer. Yeah, galvanometer is used to detect very small currents. That is not used here. Okay. So whenever you have some resistors in series, the current through the whole circuit is the same, voltage is different for each, and resistance is basically sum of all the resistances. If this is clear, can you all put some thumbs up in the group? I mean in the chat, sorry. Put some thumbs up in the chat so we can move on. You can, ma'am, which connection is, in your houses it is parallel connection. Why it's parallel? Because see, if you have 3 bulbs at home, all 3 have to glow with the same brightness. So voltage is what determines the brightness. In series what happens, the voltage is going to be shared. So the last bulb will get very little voltage, it will not glow. That is why in your houses it's always parallel. So the voltage is the same, all the bulbs will glow the same. Okay, someone had asked me that. Who is it? Okay, there's another question, ma'am. Why are voltmeters not connected in series? Very good question. Voltmeters are not connected in series because in a series circuit, voltage changes everywhere. So if you put a voltmeter in a series circuit, okay, so imagine I put a voltmeter here, I put another voltmeter here. Both these will give me 2 different values because the voltage will change throughout in a series circuit. So there is no point of measuring voltage in a series circuit, but in a parallel circuit, voltage is the same. Just like in a series circuit, current is the same, in a parallel circuit, voltage is the same. So in a series circuit, current is the same, that's why you put an ammeter in series, because wherever you put the ammeter, you will get the same value. Okay, is that clear? Any other questions? Anybody else? Any other questions? Gaurish, I read your comment, thank you. Is that clear? What is solenoid? I will explain, students. Okay, you relax, we will come to all that. Come in. Okay, let's move on. If this is clear, can you all put some thumbs up? Thumbs up, thumbs up. So we can move on to the next question. Okay, so this is a problem. Total resistance of the circuit, the current. This is 6, okay? 6. So you have an electric lamp whose resistance is 20 ohms and a conductor of 4 ohm resistor is connected to a 6 volt battery. Calculate the total resistance of the circuit. So first thing you have to do is find out if the circuit is series or parallel. If you just look at the circuit, you know the resistance are connected one across the other. They are not, both are not directly connected to the battery. One is connected after the other. So definitely it is series. So the total resistance will be R1 plus R2, which is 4 plus 20, which is 24 ohm. Unit of resistance is ohm. Next question is voltage. V is 6 volts. Now find out the current. You should be able to do it. Students, listen to class. You know, you're simply chatting in the comment box. Yes, good. Total resistance is 24. Anita Pujarti. I'm sorry if I pronounced your name wrong. Anita, good. It is 24. Yes. So what will the current be? Current will be 0.25. If you've done it, you would get it. Quickly do it, students. Quickly. Yes, 0.2. Vinay, good. Vinay is the only one who is answering all the questions. What are all the others doing? Quickly solve it. Ma'am, the resistance is 24 and current is 0.25 and potential difference. Oh my god, very good, Jayuri. Yes. Okay. So there's one more part of the question, the potential difference. So as I mentioned, in a series circuit, the potential is different everywhere. So the potential across this lamp will be different. The potential across this resistor will also be different. So you have to find out the potential across each of that individually. How will you do that? By looking at the resistance, and current is the same throughout the circuit. So you can just do current, multiply with current. Okay. So you will get it to be 1 volt. Uh, 1 volt will be across the resistor, 5 volt will be across the lamp. So as I said, potential will be different for each component in series. So that is why you can find out for each. 5 and 1 volt, Vigas, very good. Next is resistances in parallel. So we looked at how resistances are in series. Now we will look at how resistances are in parallel. So see, if this was connected like this, it would have been in series, but it is not.
Yes. How is it going?
You're asking question, ma'am.
Yeah. What is the formula for, till where did you reach, ma'am? Okay, parallel is starting. Okay, tell me the formula for series. How to calculate? Someone is telling 1 by R plus 1 by R. What if R1, R2 and R3 is there? What did you write? Yeah, these people have come to find Instagram ID here.
Yeah, they're all saying hi to each other.
I don't know, how do they know whom they are connecting? No voice, huh?
Yes, oh shit.
No voice is there.
Voice is there.
I think for that time, like now it's lagging. Okay, ma'am, continue.
Okay.
You're asking who are you, ma'am?
Who are you or?
Continue, ma'am.
Yeah.
Okay.
This is, ma'am. The one is from VIDYA.
5:30
Yes, Gaurish, magnetic field lines don't intersect. Why? We will discuss when we look at magnetism. So you have to wait, okay? We will look at that chapter. Okay, so parallel circuits are when the resistors are connected like this. So see, all of them are connected to two common points. They are not connected one after the other. They are all connected to two common points. Now if I have one more, it will be connected like this. One more, it will be connected like this. Now imagine I have something like this. Okay. Now these two are in series, but it is in parallel with the rest. So if something is connected like this, it's in series. If they are all connected to two common points, it's in parallel. So let's look at that. So in a series circuit, I said the current is going to be the same throughout, but in a parallel circuit, I will change. But V is a constant. So if I measure the voltage here or here or here or here, wherever I measure the voltage is going to be the same. That is why voltmeters are always connected in parallel, because if you connect it in parallel, even if you connect it in 2 points, both will give you the same value. The ultimate aim is to measure the voltage that is passing through. So to measure the voltage that is passing through, if you put it in series, it will just keep on changing. So to get the exact voltage of the circuit, you should put it in parallel. Okay. So let's do that. Current is changing, voltage is constant. Okay, so if you put V is equal to IR, the V will be the same everywhere. So V1 across the first component will be equal to V2, equal to V3, equal to Vn. But I, the total current, it will be split up between all components. So if you have 5, it will be split up into 5 components. So I total will be I1 plus I2 plus how many ever till In. So if I have 5 bulbs, the current will be divided between all 5 bulbs, but the voltage will be the same for all the bulbs. Okay. So yes, I is equal to I1 plus I2 plus R, I3 till how many ever I's are there, and I is equal to V by R. So V is the same, see, everywhere it's V, there is no V1, V2 or anything for parallel, because voltage is the same throughout in a parallel circuit. Yes, Samanivita, yes, it is the same. So what I will do, same thing that I did previously, I is equal to, the total current is equal to V1 R1 plus V2 R, sorry, divided by plus V3 R3 plus Vn Rn. Now I would be equal to the total voltage times 1 by R1 plus 1 by Rn. So I by V is what? I by V is equal to IR. So R would be equal to V by I. So 1 by R would be equal to R is V by I. So what is I by V? It is 1 by R. So this would be 1 by R, will be 1 by R1 plus okay. That is how you get this formula. So resistance will actually keep on decreasing in a parallel circuit. So if you have a parallel circuit and if you have 5 resistances, the total resistance will be less than the smallest. So imagine you have 5 ohm, 10 ohm, 1 ohm, 20 ohm. Imagine all of these are connected in parallel. So the total resistance will definitely be less than 1. So this is a trick for you to check if your answer is correct. So sometimes they will give you questions, find out the resistance, total resistance in parallel. Whatever value you get, it should be always less than the smallest resistance. But in series, how it should be? It should be bigger than the biggest resistance, because you are adding them. Okay. Did I write V1, V2? Okay, sorry, yes. It is a constant. Good. Whoever pointed that, it is a constant. So you're all listening in the class. Good. You don't have to have V1, V2, V3. It is a constant. So it's just V, V and V. See, V. Okay. Students, if you have a problem with the spam in the chat, you close the chat and put the video on. Okay. Okay, Dhruv. You close the live chat, put the video on full screen. Okay, so is this clear? So whenever you do questions, if you want to check, what is the tip? The total resistance in parallel will always be less than the smallest value of the resistances. In this case, it will be less than 1. For series, it will be always bigger than the highest value, which is 20. This is a small tip you can remember. Whenever you find resistance in series and or parallel, you can check your answer like this. Okay, let's move on. Question. We will find out the resistance in parallel for these. What are the values? The values are not there here. 5, 10 and 30. Okay. 5, 10 and 30. Find out the resistances in parallel quickly. 5, 10 and 30. So what is the formula? 1 by R is equal to, voltage is 12, resistances are these 3. So I1, I2, I3 you find out first. V is the same, so you can use the same V. So total current will be this plus this plus this. So total current in the circuit is 4 amps. 4 amps is divided into 2.5, 1.2 and 0.5 because in series the current is different for different components. Now you just have to do 1 by R and find out the value of resistance. So the question asks for total current also, that's why you found out the total current also. So quickly do this, students. I will give you a minute, quickly finish it off. Three ohms, yes. Mahesh, the total resistance is 3 ohm. Yes, it's 3 ohm. Okay, so done. So you will get similar questions like this to find out the resistance. Okay, so let's see if our trick worked here. So the total resistance is 3 ohm. So our resistance is 5, 10 and 30. So 3 is definitely less than 5, which means it is less than the smallest resistance. So that's how you can check. So if you get something above 5, then your answer is wrong. Okay, now someone had already asked me the advantages of parallel and series circuits. So I will first tell you the main disadvantage of a series circuit. So in a series circuit, you have a battery. Okay, let's say you have a battery and then you have a bulb. What else do I put? I will put a resistor, anything, a random series circuit. But if one component, if this one stops working, the whole circuit will stop working because current only flows through closed circuits. Or if this one stops working, this will also stop working. So if you have 5 bulbs and one bulb stops working, all the rest will stop working because current wouldn't reach them. Current only flows in a closed circuit. So that's the main disadvantage of a series circuit. But in a parallel circuit, what happens?
Will not come very fast now.
Okay.
So if you ask them a question, just go ahead.
So in a parallel circuit, what happens? This is your, okay, so this is another way of drawing a bulb, okay, don't get confused. If I have 3 bulbs, even if this bulb stops working, current can always reach this bulb and this bulb, even if this bulb stops working. So that is why in your homes you have parallel. See, in your home, if the fridge does not work, does your fan also not work? No. If your fridge does not work, only your fridge does not work. Everything else will work. So that is because they are all connected in parallel. They all individually get the voltage. That is an advantage of parallel. In series, if one stops working, everything stops working because the connection is lost. So that is one advantage. When one component falls, the circuit will not break. That is an advantage of a parallel circuit. What are the other advantages of a parallel circuit? Other advantages of a parallel circuit is it divides the current. Okay, it divides the current and it gets same voltage. So voltage is something that determines the brightness. So since everything gets the same voltage, everything will glow with proper brightness because voltage is not changing. That's another advantage of parallel. Another one is the total resistance of a parallel is least. As I said, the total resistance of parallel is always less than the smallest resistance. So all circuits will have a very small resistance, or the total resistance will be small. That is another advantage of parallel. Okay. That's why serial lights are connected in parallel, yes. Okay, yes, I have some questions. Okay, series circuit, where it is used. Okay, series circuits are used in these fairy lights, illumination bulbs. Do you know them? The ones that you hang for Christmas. So if one bulb is broken, the whole thing will break. I mean, the whole thing will stop working. That's because there are all so many bulbs connected in series. Total resistance is low. Yes, Anita, that's right. Any other questions? Right hand thumb rule, all that we will discuss. Next is Joule's law of heating. So let's look at it with a formula. So Joule's law of heating says that the amount of heat is always directly proportional to the square of current. More the current, more the heat. So in a wire, if you allow lots of heat to pass through, after some time you will feel the wire becoming hot, because heat is proportional to the amount of current, not by one factor but by the square. So the more the current, heat is proportional to the current square. So imagine how much it will heat up. It's not just proportional to current but current square. So that is why you can see gadgets and wires and all heating up if you allow current to pass through it. Now heat is proportional to resistance as well. So as I said, resistance is the opposition to the flow of current. Okay. So when I heat the wire, or when more current flows in the wire gets heated, the particles in the wire move faster. So just like I explained earlier, it's like a crowded street. Okay, imagine there's a crowded street, and in the crowded street people start running around also. So what would it be easier for you to move or difficult for you to move? So initially in the crowded street it was difficult for you to move. Now in the crowded street, when people start running around, it will be even more difficult for you to move. So what happens? Resistance is like you. Resistance increases when particles inside the wire start moving randomly, which is when temperature increases. So resistance increases when temperature increases, because it's more difficult for current to pass through. The particles are all at very high energy when you give more temperature. So resistance and heat are directly proportional. Then what else is there? It is proportional to resistance square. It is also proportional to the time. So if the current flows through a wire in 5 minutes and the current flows through the wire in 10 minutes, which one will have more heating effect? When the current flows obviously in 10 minutes. So more time it flows through, more it will be heated up. Simple logic. Okay. So combining all this, what will the total formula be? H is proportional to I square R and T. So heating of the wire is basically increasing double with current. It increases with resistance. It also increases with time. More time current is passed through, more heating. Now we will substitute I square with our Ohm's law and we will get something else. So Ohm's law is equal to V is equal to IR. V is equal to I R. So R is equal to V by I. What else can I write from here? I is equal to V by R. Now what is the formula here? H is equal to I square R T. So instead of one I and one R, I will write it as V. So I don't need this. I just wrote it for you to understand. This is not required. V is equal to IR. So H is equal to IIRT, and this I and R I will write it as V. So what happens? H is equal to IVT. So this is another formula. Okay. So these things okay. Is this clear? If it's clear, can you all give me a thumbs up, please? Function of earth wire. Yes, we will discuss fuse, we will discuss function of earth wire, all that is there in my presentation, okay? Yeah. Yes, students, if this is clear, can you all put a thumbs up in the chat so we can move on? Any doubts regarding this topic, not anything else regarding this topic? Okay, let's move on. So this is a question. The conductor having resistance of 4 ohm, 100 joules heat, find the current. So H is equal to IVT. So what we will do? So instead of V, I will write it as I square RT. And then just substitute. H is I square RT, I square is H by RT. So when you remove the square, you put a square root and then substitute the values. Okay, quickly finish this. Are you all getting? And then V is equal to Ri, you will get 20 volts. Why does the cord of an electrical heater don't glow while the electric element does? What do you mean by the electric element? Do you mean the wire that's passing through the heater? Is that what you mean? You don't see it glowing because it has an insulator around it, if I've understood your question correctly. Ma'am, if the resistance is R, if the length of the same conductor is increased to 81 times and area is 9 times, then what is the new resistance? Calculate it. What is the formula? R is equal to rho L by A. So L would become L into 81 and area would become 9 into A. You will have to also change the area because area depends on length. Area is length into length. So that also you should be careful. The cord is made of a material with a low resistance while the heating element is made of a material with a high resistance. Can you put your whole question? I really don't understand what you mean. Gaurish, can you put the full question once? I will explain it. Okay, if you're all getting this, put some fire emoji in the chat and let's move on to the next one. Now practical applications of heating is in a filament lamp. Okay, I don't know if you've seen these bulbs. Now you have all these CFL and the bulbs that are not hot, but few years back, if you switch on a bulb for 5 minutes and you go touch it, it's very hot. You will not be able to touch it. That's because as current passes through it, it becomes hot. So those bulbs are bulbs like filament bulbs, and they had tungsten. they had a filament called as tungsten, which has a high melting point. Why high melting point? Because the bulb would heat up and the bulb should still work, right? So if tungsten would melt easily, then it wouldn't be possible. So that is why it has a high melting point, because bulbs heat up back then. Nowadays we have all these cold bulbs which don't heat up a lot. And the bulbs also were filled with a chemically inactive nitrogen and argon that was basically used to prolong the life of the filament. Why should the filament life be prolonged? Because the bulb has to work for a long time. See, you don't use a bulb for a month or two, you have to use it for years. That's the ultimate purpose of buying a bulb. And these olden times bulbs would heat up. That is because they had filaments. So filaments were made out of materials that had very high melting point because they could sustain the heat. Okay. Okay. Next is the fuse. So fuse is something that looks like this. You might have all seen this at home. So in every circuit there will be something called as the fuse. Now fuse is made out of a material that can easily melt. So every time there is high current passing through the circuit, the fuse will melt. And what is the advantage of that? It will prevent this high current from reaching the appliance. For example, let's say your fridge, okay? Your fridge requires A amount of current only. Now if something more than A comes, it will damage your fridge. So what happens? In front of the fridge, you keep a fuse. So every time a current higher than A comes, the fuse melts. The fuse melts and it does not reach the fridge. So we have saved the fridge. Fuse is just a wire that can melt. So what is better, melting a wire and protecting the fridge, or just saving the wire and ruining your fridge? No, that is why you always keep a fuse. Okay. So fuse is always connected in series with the live wire. Why live wire? Live wire is a wire that contains all the potential. So from the plug there are 3 wires. So the main of all of the electricity comes through the live wire. That is why the fuse is always connected to the live wire, because as soon as high current comes, it has to melt. So high current comes through the live wire. Okay. Yeah, the temperature and then the fuse will melt. The temperature of the fuse will increase and the fuse will melt. Next is electric power. Okay, I wanted to discuss this before. The problem that was shown earlier is related to this one only. So we know, I already discussed, power is voltage times current. Now if IV is equal to IR, so voltage, current and resistance, which is the Ohm's law. So power is equal to VI. Now what I will do is, I will take things from the Ohm's law and substitute it here. So from this I get V by I is equal to R. I also get, what do I get? R is equal to V by I equals R. I is equal to V by R. So I get these 3 formulas from my basic formula for Ohm's law. Now what I will do is, I will substitute each of these in the formula for power. So first thing I will do is, I don't want V. So instead of V, what will I write? I will write it as IR. So let me erase this. Instead of V, I will write it as IR. So instead of V here, I will write it as IR into I, which is I square R. So that is my, okay, one second. See, P is equal to V into I. So yeah, there is a mistake here, students. This is I square R. So this is V would be IR into I, which is I square R. Yes, this was correct only. The mistake is here on the sheet. So it is I square times R. So you would get the formula P is equal to I square R. Okay. Next, what I want to do is, in this equation you don't see current. but in this equation there is current. So what they have done here is, instead of current they have replaced it with something else. So let's see, we will again take, for this equation what will we take? P is equal to VI, but I don't want current. So what is current? V by R. So let's substitute that. Instead of current I write it as V by R, so which is V square by R. So these are the three formulas for power. Those who want to by heart it can by heart it, but those who want to know how it came, that's why I have done this. Okay. So quickly take a screenshot. Let's move on to the next question. Next topic. This is a question. I want you to do it. Voltage is 220 volts. Current is 0.5 amps. What is the power? So P is equal to BI. Quickly solve it. This is your question. Quickly. Bismita, I am teaching all the important questions, important portions. So I am not teaching anything random. So whatever I have taught here is all very important. So you will get it as 110 watts if you do it. You can do it later. Now a bulb is rated at 40 watts, 220, find out the current. Same thing, you have power, you have voltage, you have current. Quickly take a screenshot of this as well. We will move on. So you can first find out current by P by V, and then you get R is equal to V square by R. And here one thing is, as I said, even power has different units. It has watts, kilowatts and so many things. So the basic unit is watt, but then 1 kilowatt is 1000 watts. So every time you do the question, your answer should be in SI units. Okay. So 1 kilowatt would be this much. Another question, this also you can take a screenshot quickly and solve it. So this question I will just explain it quickly. So a refrigerator is rated at 400 watts. That is the power of the refrigerator, and it works 8 hours per day. In every day it works for 8 hours. And okay. So calculate the cost of using these appliances for 30 days. So there are two appliances, we will do one, the other you will do as homework. So we will do the refrigerator. So the refrigerator has a power of 400 watts. It works for 8 hours in one day. You have to calculate how much it will be if you have to use it for 30 days. Okay, and the cost of 1 kilowatt is rupees 3. So first thing first, you have to find out how much. So this 400 watts for 8 days and then for 30 days. So 400 into 8 into 30. Okay, 400 into 8 into 30. This 400 is going to be converted into kilowatts. Why did I do that? Because it's given to us for 1 kilowatt, it's 3 rupees. So let's find out how many kilowatts is this. This 400 will be 0.4. So when you do this, you will get the total energy for 30 days, which is 96 kilowatts per hour. So if you use the refrigerator for 8 hours a day and that for 30 days, you will totally use 96 kilowatts per hour. Now 1 kilowatt is 3 rupees. So 96 is for your fridge. You have to do the same thing for your iron box. So that will be 45. So 96 plus 45 into 3 will give you your total current bill. Okay. 423. Yes, good. Very good. Who is that? Jayuri. Very good. Okay. So what you have to do is the power into how many hours a day into how many days. That will give you the total power for that particular appliance. Now you have two appliances. So these two together added into how much it is for 1 kilowatt. That will give you the total. Very good, Gaurish. 423. Yes. Okay. Now the next unit is light, reflection, refraction, all that we will cover. So we will take a 5-10 minutes break. Okay. So electricity is done. You can go for a 5 minutes break. We will continue back at, what is the time now? 5:40, 5:45. Okay. Can you all hear me? Can you quickly confirm if you can hear me? Okay. Can you all hear me? Please tell me if you can hear me or not. If you can please hear, okay, you can hear me, yes. Okay, so let's start the chapter reflection. We finished electricity, now we'll start with reflection of light. So, reflection is basically the bouncing back of light when it hits the surface. So, there are two things that you need to know for reflection, which are the laws of reflection. That is, this is how a reflected ray is, okay. So, let's start by, this is a mirror, okay. So, for light to reflect, it has to fall on a mirror. If it falls on glass, okay, it will pass through, it will never reflect. Light will always reflect if it passes through a mirror. So, light falls on a mirror, this is the incident ray. Incident ray is the light that is falling on the mirror. This is reflected, okay. Now, to draw the incident ray and reflected ray, you always draw a normal. What is a normal? A normal is a line that is parallel to the surface. So, if you have a mirror like this, this is your normal. Now, if you have a mirror like this, normal is perpendicular, okay. So, if you have something like this, normal is like this. Now, if this is your surface, then normal is like this. A normal is a perpendicular line drawn from the surface of a mirror. So, here this is the mirror, so this is the perpendicular line, this is the normal. Now, the angle between your angle of incidence and normal is, the angle between the incident ray and normal is angle I. The angle between the reflected ray and the normal is angle R. Now, the first law of reflection is that angle I should always be equal to angle R. The incident ray, the angle of incidence equals the angle of reflection. Now, second law, two most important things I said. The first law is angle of incidence and angle of reflection should always be the same. Second law is that the incident ray, the reflected ray and the normal, all three should lie on the same plane. See, the incident ray, reflected ray and normal, all three should lie on the same plane. Incident ray, reflected ray and normal, all the three should lie on the same plane. Okay. Let's see. So, those are the two laws of reflection, very important. This is a question that's very important. First law, all three should lie on the same plane. Second law, angle I should be equal to angle R. Now, there are always two kinds of images that are going to be produced. There are real images and virtual images. Real images are images formed by actual meeting of real light rays, and virtual images are when light rays do not actually meet, but they are made to meet. We will discuss about that with figures. Now, image is formed by a plane mirror. So, as I said, this is the mirror. So, if this is the mirror, this is the normal, aligned perpendicular. So, this is your normal. So, angle of incidence, angle of reflection, these two angles should be the same and all these three should lie on the same plane. So, this is a good circuit, a good image because it obeys both the laws. Now, what happens? From here, where is the image formed is what we will see. We see how the light rays are going, but we will see how the image is formed. So, look at this ray. It's going and hitting the mirror perpendicular. So, basically it's going along the normal. See, this is the normal, this is the ray. Both of them have the same direction. So, if a ray is going along the normal, it reflects back along the same path. So, this will be reflected along the same path and this will be reflected along this path at an equal angle. Now, what I will do is I will extend both my reflected rays. What rays? Both reflected rays. So, let us see that. So the first reflected ray is this because it's reflected along the same path. So this is the reflected ray. Now this is my second reflected ray. I am extending these two, and the point where they meet is where I will have the image. So these two rays come from A, so it will give you the image of A, which is A dash. Now if I take rays from B, I will get the image at B. So you can see the light rays are not actually going there. The light rays are going this way and this way, the green paths. But I am extending those and making them meet at a point to get the image. Those kinds of images are called virtual images, where the actual light ray don't meet, but when you extend them backwards, they meet. Those kinds of images are called virtual images. Teach how to draw mirror. A mirror is just a straight line with lines. What else? Are you talking about lenses? Okay, is this clear? So this is how images are always virtual and they are erect. So you can see they're all facing up, that's why they're called erect. And the size of the image is the same as the size of the object. An image is formed behind the mirror. It's not formed on the mirror, it's formed behind the mirror. So you can see this. Okay, so this is how images are formed on a plane mirror. The two rules are, if a light ray is parallel to the normal or it's along the normal, it's reflected along the same path. Now it's falling at an angle, it's reflected at the same angle, and you extend those two, you get the image. If this is clear, can you all put some fire emojis in the chat? Let's have some energy, guys. Come on. Okay. Quickly, can I have some emojis? I mean fire emojis only. So the first thing, okay, I understand. Maybe you asked me how to draw spherical mirrors. So what we just saw was a plane mirror. Now what we will be drawing is spherical mirrors. So spherical mirrors are of two types, something like this, something like this. Okay, so you might have all heard about relationship between curvature and focal length. We will discuss. So you might have all heard the word concave mirror and convex mirror. So what is a concave mirror? What is a convex mirror? So a concave mirror is a mirror that looks like a cave. So it's like this. You are entering a cave. Okay, if this is your mirror and you are entering it, it's like entering a cave. That is concave. Now convex is the opposite. This is convex. Okay, I don't have images of that. So a concave mirror is a mirror that looks like a cave. Convex is the opposite. So you remember concave. So concave is like entering a cave. So the other one is convex. So if you learn one properly, you can just remember that the opposite is the other one. Okay. So a concave is one that looks like a cave. So it just enters. Now we will learn some terms related to both concave and convex. The first one is pole. Pole is basically the center of the reflecting surface. This is the reflecting surface and the center of the reflecting surface is the pole. Okay, center of the reflecting surface. Now C is the center of curvature. What is that? See, this basic mirror is a part of a big sphere. It's a part of a sphere. So the center of this sphere is called the center of curvature. The mirror forms a sphere. The center of that sphere is called the center of curvature. Center of the sphere from which the mirror is being a part. Next is the radius of curvature. It is the distance between the center of curvature and the pole. That is called the radius of curvature. Now principal axis is the imaginary axis that is passing through P and C. So this is principal axis. Okay. So this part is actually not there for the mirror. I have just drawn it to show you. What is C? C is basically the center of the sphere that's forming the lens. Is this clear? All these? Can you put some emojis? Can you put some thumbs up if this is clear? Ma'am, please, difference between converging and diverging, I will explain. What is aperture? How to find focal length? All that we will learn. Difference between principal focus and principal axis. That also we will learn. Okay. Now, this we just discussed. Concave and convex. Aperture. Aperture is this reflecting surface. How much it is broadened is your aperture. Relation between radius of curvature and focal length someone had asked. So, the radius of curvature is always 2 times the focal length. So, if this is your concave mirror and this is the center of curvature and this is R, this would be F. R would basically be 2 times F. Okay, now we will look at how to make ray diagrams. We looked at how to make ray diagrams on a plane mirror. Now we look at how to make ray diagrams on a concave mirror. So first thing, draw a concave mirror, draw the principal axis. This is the center of curvature. F should be between these two because R is, if this whole thing is R, F should be at the center. Okay, and then what happens? I will okay. So first I will draw a normal. So since this is something like this, the normal will be perpendicular to that. So it would be like this. So it's a surface like this, so the perpendicular will be like this. Now I have an incident ray and I have a reflected ray. So this is I, this is R. So that is what is shown here. So angle of incidence, angle of refraction, and then the normal. This is the first way that rays pass through in a concave mirror. Okay, yeah. So any ray that is passing through the mirror like this will be reflected through the focus. Point number 1. Now point number 2 is if any ray is passing through the focus, which means it's passing through the focus. Any ray that passes through the focus will be reflected parallel to the principal axis. So this ray will be reflected like this. So any ray parallel passing to the focus will be reflected parallel to the principal axis. And then again, any ray, okay, which has the normal along the principal axis, it will be reflected like this, I and R. Okay. So that means here how would it be? I will use a different color. Okay. So if this is the normal and this is the incident ray, it will be reflected like this. Now all of these three together will meet here. Okay. So it might be confusing there, that's why I have put individual pictures. So first thing, if the normal is through center of curvature, the reflected ray will pass through the focus. If the normal is, if there is no normal, it just passes through the focus, it is reflected parallel to the principal axis. If the normal is along the principal axis, it is reflected like this. Okay, let's move on. Now we will look at how the position of the image will change with the position of the object. So first thing, let's make a table. Okay, there is a table here already. So first thing, the object is at infinity, the image is at the focus. Let's see, when I say object is at infinity, what I actually mean is the object is very far away from the mirror. So object is far away. So what happens? Let's draw the ray. The first ray, I have my normal passing through C. So what happens? This ray should be reflected through the focus. Rule number 1. So it's parallel to the principal axis. It is reflected through the focus. So any ray parallel to the principal axis should be reflected through the focus. Now any ray passing through the focus should be reflected parallel to the principal axis. So this is where my image is. Every time images are formed when two rays meet. Okay. So if two or more rays meet together, that particular point is where you get your image. So if I look at my image here, the image is at F. Now what I will do is, I will move my object to C or somewhere closer to C. Okay. Right now object is at infinity, image is at F. But now I will move my object to a point here. See here. So what happened to the image? The image was at F. It also moved to this side. See, the image is now here. So as I move my object closer, my image moves away. So if my object moves like this, closer to the mirror, object moves away from the mirror. As I move it closer, it will move away. Now what happens? If I move my object to C, this will also shift again. See, now I have my object at C. My image was between F and the pole. Now it shifted to the F. And then what happens? I will move it beyond C. I will put my object here. Image will again move. I have put my object between C and F. Image moved from here to here. So object is moving that side, image is moving this side. Okay. So that's how it moves. Object is moving that side, image is moving this side. So that is why this table is important. Okay. So at infinity is the farthest point for the object. So at infinity, what happens? This object forms an image which is at the point focus. Now from infinity, object is moved to the next point, which is C. What happened to image? Image came closer. Image becomes between F and C. And then object I move again further, image will come closer. This moves this side and object moves this side, image moves this. Yes, you can get the object at C only when you keep the, you can get the image at C only when you keep the object at C. So this is how it changes. Okay. So all the ray diagrams are there here. You can go through them individually. So you have, in every case you take two rays. The first ray parallel to principal axis and then it passes through the focus. Another ray passes through the center. It moves undeviated. So the main thing that you have to remember here is, as the object moves closer, the image moves away from it. As the object moves closer to the mirror, the image moves away from the mirror. How to remember this table? I have a shortcut for you to remember this table. You have to know object, okay, image. Let's look at the different positions. It can be at infinity, and after infinity comes C, after C comes F, what else? And then the pole. These are the different points on the mirror. So if this is a mirror, infinity is at the end, and then the center, and then the focus, and then the pole. So if your object is at infinity, okay. So first thing, if your object is at infinity, then the image is at F, okay. Object is at infinity, image is at F. And then what I do? I will bring my object to C. From infinity, I brought my object to C. Or between infinity and C is also there, no? Yeah. Okay, I will. Yeah, beyond C. So now first my object was at infinity, and then the object is between infinity and C, okay, between infinity and C. If it's between infinity and C, the image was first here. So if the object is between these two, the image should also shift. So it should be between F and C, okay, between F and C. Now what happens? From C, I will keep it at C. So what happens? Are you understanding this? So every time the object shifts, the image also shifts. I think I should do a better work. So let's put infinity, C, F and P, okay. Here I will put object, here I will put image. So first, object is at infinity, image is at F, and then I shift my object, it will move, the object becomes here, image becomes here, and then object becomes here, image becomes here. So C and C. And then what happens? Object becomes here between C and F. Where does image become? Here. Between C and F, this will be beyond C. And then what happens? Object becomes between F and P. So image already reached here. So image will be at infinity. Are you getting this? If you are understanding this, can you all put some thumbs up in the chat? Can you all put some thumbs up so I understand that you are understanding? So every time the object is moving this way, the image is moving the same way in the opposite direction. So those of you who want to take a screenshot of this, quickly take a screenshot. So some of you still haven't understood. I will explain it once again neatly. Okay. So let's take this. Okay. So first, my object is at infinity. Object, image. My object is at infinity. Okay. So when my object is at infinity, all the rays together come, I will get my image at focus, okay. So the image is at focus. This you have to know, okay. If object is at infinity, image is at focus, that you should know, that's the first case. And then after infinity, there is C, then there is F, and then there is the pole, F and C, okay. So from infinity, I move the object was initially here, now I have shifted my object to here. So it is basically between infinity and C. So what happened? My image was initially here, so this image also shifted here. So the image is going to be at C, between C and F, okay. Now what I will do next? I will again shift my object from this position, I have reached to C. Same thing, image also, from here it will shift to C. So C and C, okay. Now again, object I am moving closer to the lens, to the mirror. So now I have kept it between C and F. Now where will my image be? My image will also be between C and infinity. So C and F, C and infinity. And then what happens? I move it even more closer, I bring it to F. So when I bring it to F, what happens? This goes to infinity. So if this is at F, this will be at infinity. And then it can go again. This will again be If I move it here, if the object is between F and P, then the image will be behind the mirror because it has nowhere else to go. We've already reached infinity. So if it is between F and P, here the image will be behind the mirror. So it will be a virtual image. Okay, I hope you've all understood now. Let's move on to the next question. Yeah, so this is the case that I just mentioned. If your object is between F and P, see, if the object is between F and P, image already reached infinity, so there's no more space to go. So what happens is, it will form a virtual image. How does that form? So you have your first ray, okay, the first ray is passing through the center, so it goes undeviated, and then another, this is the object, okay. So from the object, you have a ray hitting the mirror, it goes back along the same path, and then the second ray, it is parallel to the principal axis, so it should be reflected through the focus. So from the object, first ray passes through center, second ray passes parallel, so it passes through the focus. Now these two rays are not meeting. When do you get an image? An image is only when the rays are meeting. So what happens? You have to extend these rays backwards. That's where you get the image. And these images are not produced by actual rays. That is why it's called a virtual image. Okay, let's move on. Now, yeah, uses of concave mirrors, they are used in torches, they are used in shaving mirrors because you need to see a larger image. They are used in solar panels and all that. Quickly take a screenshot of this. Okay, next is images formed by a convex mirror. So till now we discussed concave. Now we will discuss convex. So convex is the opposite shape of a cave, that is convex. So this is a convex mirror, principal axis, this is the focus. So the center of curvature should be twice the focus. So this is your center of curvature, this is your pole. Now the object is always kept in front of the mirror. Okay, so the object is kept here. So from here I have two rays. The first ray is parallel to the principal axis. So if a ray is parallel to the principal axis, in a concave mirror it should reflect through the focus. But in a convex mirror, it just randomly goes. Okay. And then you have another ray that's falling at an angle. This is deviated along the same path. Now if you extend both of these, you will make them meet here. That is where your image is going to be. So this image is going to be virtual because the actual rays don't meet here. Convex mirrors are mainly used in rear view mirrors, and they are used in wherever you need a bigger field of view, because you can see the virtual images. Okay. Now position of the image, you will see. Okay. So here you don't have a lot of cases. So if the object is at infinity, the image is at the focus. Now if the object is between infinity and P, it is between infinity, P and here F on this side. Only two cases. Either the object is at infinity or the object is between infinity and P. What is P? P is the center of the mirror. So if this is a mirror, no, this is the mirror, this is P. Either it's very far away or it's between that far away position and P. That's the only two cases you have. And in both the cases, the images will be virtual, because on a convex mirror, the actual rays cannot move because they are moving in random directions. Okay. Now these are the sign conventions. These are very important for you to do problems. Okay. Sign convention is very important. So every time you have a mirror, any measurements that are made towards the left will always be negative. Any measurements made towards the right will always be positive. Any measurements in the up direction will be positive, down direction will be negative. So let's see. Now this is what mirror? This is like a cave. So this is a concave mirror. So for a concave mirror, the focus is here, the center of curvature is here, the pole is here. All measurements are made from the pole. The starting point is always the pole. So from the pole, how do I measure F? Is it in the right direction or the left direction? It's in the left direction, so it should be negative. Now how do I measure C? This is also in the left direction, so this will also be negative. Now the object height, it's upward. Upward is always positive. Okay. Now let's see for a convex. So for a convex, again I start my measurement always from the pole. How do I measure F? It is in the right direction, so this is positive. C is also in the right direction, so this is positive. Height of the image is positive, but look at the object, it's downwards. Any measurement downwards is negative. So things you need to remember, all measurements start from the pole. Any measurement to this side, to the left is negative. Any measurement to the right is positive. Always start from the pole. Okay? Is this fine? Now the mirror formula is 1 by u plus 1 by v is 1 by f. U is basically the object distance. So from the pole, however far the object is, that is u. Now v is basically image distance. From the pole, however far the image is, that is v. And f is the focal length. So how much is the focus where the image is, that is your focal length. And magnification is basically how much your image is magnified, how much bigger it is or how much smaller it is compared to your object. So that is basically given by height of the object, by height of the image by height of the object. It's also given by V by U. Okay, quickly note down this formula. But when you do questions in optics, with respect to mirrors, formula application is easy, but you need to know what is positive, what is negative. Okay. Ma'am, does it mean any object in those sides depends on? I didn't understand your question. If you mean object as in the object that you are keeping in front of the mirror, if it's measured from the principal axis in the upward direction, it's positive. In the downward direction, it is negative. Okay. Now, if M is negative, image is real. What does that mean? That means that the image magnification is negative. So V by U is negative. So whenever M is negative, image is real. Whenever M is positive, image is virtual. And whenever M is 1, that means it is not magnified. The height of the image and the height of the object are the same. There is no magnification there. That is when M is equal to 1. Now, if H dash greater than H, what does that mean? This is the height of the image, this is the height of the object. So height of the image is bigger than object. Other way around, object is bigger than image. Now magnification on a plane mirror is always positive, and this plus sign indicates virtual image. Okay, so remember this as well. Whenever M is plus, it represents a virtual image. And where do you get a virtual image? On a concave mirror or a convex mirror? On a concave mirror, you know the actual rays meet. So it's always on a convex mirror that you get real images. Concave mirror, you get real images. So plus sign indicates virtual image. So virtual image is always on a convex lens. Sorry, convex mirror. Okay. So when M is plus 1, it's always a convex mirror because it indicates virtual image. Virtual images are always formed for convex mirrors. So there's a question here. So for questions like this, you actually need to know the sign convention. Let's do this. An object is placed on the principal axis of a concave mirror. Concave mirror. Let's draw a concave mirror. Let's draw the principal axis. Focal length 12 centimeter. So F, this much is 12 centimeter. If the object is at a distance 18 centimeter, so this is 18 centimeter. Calculate the image distance. You have to calculate V. So let's find out if F and all these are positive or negative first. So first thing is, from the pole I am measuring towards the left. Whenever I am measuring towards the left, it is going to be negative. So this is minus 12 and minus 18. Okay. So minus 12 minus 18. And then you just do the substitution, you will get. Now to find out magnification, M is equal to V by U. But we know that U is negative here. U is negative here. How will V be? V is also negative. Okay. Now since it's a concave, magnification is minus of V by U. So for a concave, magnification is always negative. Remember I said magnification is plus 1 when it's a convex. Here it's a concave. For concave, magnification is always negative. Okay. So is this clear? So the only challenging part for these kinds of questions is to identify which one is negative, which one is positive. It's not challenging, you just have to know the sign convention. If you measure it towards the left, it's always negative. Okay. Is this clear? Now you can see from the magnification it's negative 2. So whenever it's negative, it is always real. If it's positive, it's always virtual. It's negative, so it's real. And since it's negative 2, it's always inverted and it's going to be larger than the object. Okay, because it's negative 2. So if the object is 5, the image is going to be negative 2 times 5, which is going to be 2 times smaller than 5. That's why it is it's larger than the object, so 2 times bigger than, yes. Okay, is this clear for all of you? Can you all let me know? Next is refraction. So some of you asked me how to show the ray diagrams on a glass slab. So that is basically refraction. So refraction is how light passes from one medium to another. So if this is your medium, this is your normal, okay. So this is medium 1, this is medium 2, okay. So this is your normal, okay, medium 1, medium 2. So whenever light passes from one medium to another, by two mediums what I mean is air glass or water air, two different materials, okay. So whenever light passes through this is a normal is again a perpendicular between the mediums. So whenever light passes through from one medium to another, it always bends. That is because it changes its speed. So the light can travel in air with a particular speed, it cannot travel with the same speed in water, it cannot travel with the same speed in glass. That is why it bends. So you can see if I have an incident ray, once it touches the surface, so imagine this is air, okay, and then it moves to water. The moment it passes on to water, what happens? It cannot move that fast just like it was moving in air. So its speed reduces. So it moves like this. It bends towards the normal. It takes a slower path because it goes to a higher denser medium. So it's difficult for it to move fast there. So the same thing happens here. So you have your normal, you have an incident ray. This is air, so it cannot move with the same speed as it moves in air when it moves to glass. So what happens? It moves very close to the normal. It takes the shortest possible path because it can only move slowly. But once it reaches the other surface, which is again the surface between the next two mediums, what happens? This is from glass to air. So it can move very fast because it was in glass. From glass to air it can move fast. So that is why it bends away from the normal. So this angle between the normal and the incident ray is angle I. The angle between the reflected ray and the incident normal is angle R. Okay, is that clear? So this is refraction. Refraction is the bending of the light ray when it passes from one medium to another because the speed changes. Whenever it bends from a light medium to a dense medium, it is slower. So it bends towards the normal and the other way around. Yeah, these are the two things. So you can see from rarer to denser it bends towards and the other way around. You can quickly take a screenshot of this. Okay. Now, refraction also has two laws. Okay. The first law is same thing. All of them have to be on the same plane. The incident ray, the refracted ray, the normal, they all have to be the same plane. Another law is that sine of your angle of incidence and the sine of angle of refraction should give you N. Okay, so N is basically refractive index. So sin I by sin R should be N. N is the refractive index of the material. It will keep changing from one material to another. Now N also has another formula, which is velocity of light in medium 1 divided by the velocity of light in medium 2. Okay, so velocity of light in air will be different compared to velocity of light in water or in glass. As I said, the speed changes. It cannot move that fast in dense mediums like it moves in light mediums. So the velocity keeps changing. So the ratio of velocity will also give you refractive index. Now with respect to vacuum, refractive index is basically the speed of light in air divided by the speed of light in whatever medium it is in. Speed of light in air is always 3 into 10 raised to 8. Okay, that divided by V. Alright. Now there's a quick question, it's a direct question. You just have to find out the speed. Okay, so refractive index is given. This is the formula. N is equal to C by V. Direct question, you can do it. Okay. Ma'am, answer in which fuse you should use for an electric device. Okay, I will discuss that. Next is the refraction by spherical lenses. So we looked at mirrors till now. We looked at a plane mirror, we looked at a convex mirror, concave mirror. Now we will look at lenses. So in lenses, light is not reflected because it's not hitting a reflecting surface. In all of the other three, it is hitting a reflective surface. But here, what it is doing, it is passing through. So you have a glass, a lens is made out of some kind of glass. So what happens when light passes through glass? It bends and it passes. Why does it bend? Because it's moving from a medium, which is air, to another medium, which is glass. So it cannot move with the same speed. So light from air will bend when it passes through glass, and then it will bend again when it comes out. So that process is refraction, and that's going to happen in lenses, in spherical lenses. There are two kinds of spherical lenses. The two are convex lenses and concave lenses. So a convex lens is a lens like this. Concave lens is a lens like this. So this is also similar to concave mirrors. See, it's just like you're entering a cave. See, it's just like a cave. It's bent. So concave lens has a cave-like structure. Remember one, the other is the opposite. Okay, so a concave is where it's curved inwards, thicker at the edges than at the middle. Now these are diverging lenses. Somebody had asked me. So converging lenses are convex. So that you can remember like this. Convex, converging, CONV, CONV. Okay, convex lenses are always converging, CONV, CONV. This is a shortcut. Okay, so the other one, which is the other one, concave, so that has to be diverging. Okay, very good, Gaurish, you got the answer. Good, good. Yes. Okay, is it clear? Okay, now just like we looked at the parameters, here also what kind of a lens is this? It's not a cave, so this is a convex. So from the convex lens you can see light coming, but see, they're all bending. Why are they bending? That is because they're refracting. Once they enter the glass, they're bending, and they're bending and they form at a point. Okay, now for a concave, what happens? All of these rays come, concave is diverging. Okay, one more thing I need to tell you here is convex is converging, so that you can see all the rays converge and meet at a single point. But concave is diverging, so you can see each of them moving in random directions, they're diverging. Okay, now 3 rules to know before you understand or you draw ray diagrams. Okay, so the first rule is, let's just draw the basic thing first. So you have a lens, you have the principal axis, here you have focuses on both the sides. Why focuses on both the sides? Because light passes from one side to other. It's not like a mirror where light hits and comes back. It passes through. So you have to have focus on both the sides. You have a second focus also on both the sides. So this is how a lens is. This is a which lens? Convex, because it is not like a cave. If it's a concave, it would be like a cave. Okay. So let's move on. Yeah, first thing, this is the same rule that we looked at in mirrors. Any ray parallel to the principal axis, if it was a mirror, it would have reflected like this to the focus. But this is not a mirror. Ray will pass through. So what happens? It passes through. So it passes through the focus. In lenses, it reflects through the focus. In mirrors, it reflects through the focus. In lenses, it passes through the focus. This is the first ray. Next point is any ray that is passing through the center of the lens passes undeviated. Okay. Any ray passing through the center will move undeviated. Next is the opposite of the first one. So here a ray parallel to the principal axis will go to the focus. So what happens if the ray comes to the focus itself? If the ray comes to the focus, it will be parallel to the principal axis. Vice versa. If it passes through the principal axis, it goes to the focus. So if it comes through the focus, it will go parallel to the principal axis. So these are three rules for drawing ray diagrams. This will be the same for convex and concave, but we will look at concave as well. Okay. This is for convex. Yeah, same thing. Now for concave, what happens? The same thing, the exact same thing. Any ray passing to the center will pass through the center undeviated. Next one, any ray parallel to the principal axis passes through the focus. But here what happens? Any ray passing parallel to the principal axis, since concave is diverging, the ray has to spread. So when you extend it backwards, it passes through the focus. That's the difference. This we already saw. Any ray parallel to the principal axis is going to the focus. But if it is a concave, since concave is diverging, it diverges, but when you extend the refracted ray backwards, it will pass through the focus. Next, opposite. If it goes through the focus, it passes parallel. But here what happens? Again, if it comes this way, it passes parallel, but the incident ray extended backwards is what is going to pass through the focus. So the incident ray here is in a random direction. If it is reflected parallel, then if you extend the incident ray, it will pass through the focus. So this is a comparison between the two. Okay. Next is again the different positions for convex lens. Let's look at that. First, the object is beyond infinity. It is forming an image at F. Then what happens? The object came closer. So this was infinity. Now it's between infinity and 2F. Where was the image here? It was at F. Now the image shifted. It came to between F and 2F. Now what happened? Next I'll bring the object even more closer. I brought it to 2F. The object was here. I brought it here. So what happened to the image? It also shifted. The image was earlier here. It shifted. Next what I will do? I will keep the object between F and 2F. When the object is between F and 2F, my image will shift even further. Let's see. See? Object F and 2F, image shifted even further. So here what's happening is object is moving closer to the lens, image is moving away from the lens. Same thing. So how can you make a table here? You will make a table with all the points. Object, image. So first point for object is infinity, then infinity and 2F, then 2F and F, then it can be at 2F, and then it can move even more closer. So when it's at infinity, it's at F. That you need to know. When it's at infinity, it's at F. First thing. When it's at infinity, it's at F. This is the first thing. And then from infinity, it is between infinity to F. So what happened? It also will shift from F and to F. So you need to know these points. So infinity to F, F. Same thing. If you just sit and work it out, you can get it. So as the object moves closer, the image also moves away from the lens. Now for concave, what happens? is always virtual. So however it comes, only two things. If it's at infinity, image will be at focus. If it's beyond infinity, it will be between focus and O. O is the optical center, which is here. This is O. Okay. So you can see the first ray through the center goes undeviated. A ray parallel to the principal axis is diverging. Okay. Let's move on. Now for lens, okay, what is the difference between this and the previous? For mirror, the formula was 1 by V plus 1 by U is equal to 1 by F. But for a lens, the formula is negative. Remember that, okay? For the lens, the formula is negative. For the mirror, the formula is positive. So again, everything else is the same. M is V by U. Now if M is negative, the image is real. In the previous case, if M is negative, image was real itself, no? Yeah, it was real itself. Okay, all of this is clear. Let's look at a question. A concave lens. Concave lens should have the shape of a cave. Concave lens. Okay. F is equal to 30 centimeters from the lens. Forms an image at 20 centimeters from the lens. Also find out the magnification. So image is at 20. Okay. So for a concave, image is always virtual. So virtual images are always formed in front of the lens. See, like this. Virtual images are always formed in front of the lens. You need to remember that as well. For convex, image is always on this side, but for concave is always formed, somewhere here. It's at 20, so here. So both of these, if you take the pole to be the center, from here, okay, so from here you are measuring towards the left. So when you are measuring towards the left, it's always negative. So both are negative here. F and U, V both are negative here, because for a concave, image is always formed in front because it's a virtual image. And then you substitute negative, negative, you get U. Magnification is V by U, both are negative, so you get this. And as M is less than 1, it's obviously smaller than the object. So you have to remember sign convention when you do mirror formulas or lens questions. You have to be very important. You have to know where the image is going to be formed. So for lens, if it's a concave, image is always on the other side, positive. For lens, if it's convex, other way around, this is concave. For lens, if it's concave, image is always formed here, positive. Convex, image is formed here, negative. Other way around. If it's on this side, how is it? It's positive. Okay, one more time. Concave, okay, concave, this side image is negative. Convex, this side image is positive. Yes, and just, oh my god. Okay, next thing is power. Yes. Minus V by U, it will become positive, like M is equal to V by U. It depends on the symbol of V and U. So if V and U are positive, minus V by U will be negative. No. If V and U both are, if one of that is negative, then it will change. Okay. Next is the power. So power basically tells us how fast it converges or how fast it diverges. For example, if you have a lens like this, how fast it diverges, or if you have a lens like this, how fast it converges is given by the power. So sometimes it converges here, sometimes here, sometimes here. So where it converges or where it diverges depends on the power. Okay. So it is the degree of convergence or divergence, and it is the reciprocal of focal length. So P is 1 by F, and the symbol or the unit is diopter. Okay, so for convex lens, let's think. Convex lens is a lens that looks like this. So for the convex lens, where is the focus? It is going to be positive because the image is going to be produced here at plus f. So convex lens, you will have 1 by plus f, which is plus d. Concave lens, the image will be here, so minus. Okay. Now this is a simple question, you just have to do 1 by f. Yeah, 1 by f, you will get the answer. Another question, if A and B are plus and minus, what type of lenses? So if it's positive, it will always be a convex lens. If it's negative, it's always going to be concave. Why like this? Because this is concave. Image is going to be in front. It's going to be minus f. Convex, image is going to be on this side. So plus f. Okay. Next is the human eye. Okay. We will look at the different structures of a human eye. So you can see first thing is the cornea. Cornea is the outermost part of the human eye. So this is the part that is most exposed. So in real life, this is your cornea. The part that is most exposed to light, the one that is most refractive. Okay. So that outer surface is the cornea. And then the lens, which is the lens. Where is it? This is the lens. Okay. So lens is made out of a jelly-like structure and it focuses the image. So the lens can change its shape and it focuses the image. Yes, that's right. Okay. Next is the iris and the pupil. So iris is basically this muscle here that's holding the lens. So the two irises together hold the lens. So this iris can move and adjust the shape of the lens. Pupil is this part. So this is the pupil of your eyes. So pupil is basically something that can control the amount of light. So if you're staring at something bright, you always do this with your eye, right? You do this because that much light intensity your eye cannot take. So that is when the ciliary muscle or the iris, it moves the pupil and the pupil becomes small because it does not want that much light. And if there is some place where you can't see, the pupil becomes dilated. It becomes dilated because it can take in lot of light. And then the next one is the retina. So retina is this membrane. So that is where all the light falls and focuses and you get your image. It has lots of sensitive cells that's able to identify the image. Okay, what else? Ciliary muscles, again they help change the shape of the lens. Now there is an optic nerve. This optic nerve, it transfers the image or whatever you see, it transfers that to the brain. And then there are 2 points, far point and near point. Okay, far point is the farthest image that you can see and near point is the closest you can see. So if I keep a book, I cannot read it like this. I have to keep it at one particular point, only after which I can read that. That is my near point. So it's usually 25 centimeter. You can all go home and you're all at home, no? So you can try that. If you take a book, if you keep it more than 25, less than 25, you can't read it. Only if it's after 25 you can read it, because this 25 is your near point and far point is how farthest you can see. Usually it is infinity for human eyes. Now next is accommodation. Accommodation is the ability of the eye to adjust according to the light coming in. So you can see right now light is diverging. So it's coming from a very different far source. So that means your lens is expanded so you can take in maximum light. Now if light is coming from a focused point, then your lens is compressed or it's brought close because it needs to accommodate only a small amount. Okay, so this is mainly done with the help of ciliary muscles. So the lens becomes thick and thin. It controls the amount of light entering. So this process is called as accommodation. Okay. And then the defects in a person's eye, these are the different defects and these are how it can be corrected. So the first one is myopia. So myopia is when a person cannot see nearby objects. So if he cannot see nearby objects, you use a concave lens. Hypermetropia is when he cannot see distant objects. It's called long-sightedness. You use a convex lens. Now, myopia is when it mainly due to aging, okay. So the eye gradually becomes tired, it's very difficult to see nearby objects, you use a bifocal lens. And cataract is when the eyes become cloudy, so you will not be able to see properly, and one solution for cataract is surgery. So you have to know this, you have to know the defect, the description, and how to cure it, okay. Let's move on. Now for myopia, this is how you cure it. So for myopia, what happens? The light rays come and focus at a point before the retina. We already discussed, only when the light ray falls on the retina, you get the image. So it falls at a point before the retina. So what happens? You put a lens in front of it. So the lens makes sure the light ray focuses at the retina and it helps you see clearly. That's why the concave lens helps. Now same thing for hypermetropia. You use a convex lens, because in this case the light ray focuses at a point behind the retina. So you have to reduce the focus, you have to bring it back to the retina. That's why you use a convex lens, okay. You don't have to learn the diagram, this is just for you to understand. You have to know how the defects come. Yeah, these diagrams are simple, right? You can just go through them as well. Cannot see the board clearly. Okay. This we just discussed now. Next is the refraction of light through prism. Okay. So in a prism, what happens? This is glass, this is air. So normal is always a line perpendicular. So here the normal will be like this. Now if I have an incident ray, this incident ray comes, falls on the prism. So once it touches this point, it is not going to be reflected back because the prism is made out of glass. So it's definitely going to pass through. But it's not going to pass through along the same path because it's a glass. So the speed of light will change. So the light will bend, the light will refract. Now how does it refract? It refracts like this. So you can see the dotted line is the path if the glass was not there. But because the glass is there, the light bends, it takes a path like this. Now once it reaches the second boundary, what happens? It's again air, there's a different medium, so it refracts again. If there was no air, this would have gone like this, but it does not, it bends. So you can see in a prism, this is how light ray passes. It bends twice. Why does it bend twice? Because there are two mediums, air, glass, glass, air. Okay. Now all the angles are mentioned here. So angle I, angle between the incident ray is angle of incidence. Angle R is the angle of refraction. Now this angle is called the angle of emergence, the angle that comes out. And you can see this was the actual path if the glass was absent, but this is the path that it takes because the glass is present. Now if I extend this and this, I get an angle here which is my angle of deviation. So I extend this ray and this ray. So this angle is angle of deviation. So it basically gives the amount by which the rays would have been gone if the glass was absent. Okay, let's move on. Now prism helps to split light into different colors. So each white light has different colors. They have different wavelengths inside them. So each wavelength will have a different speed. So when they are passing through the prism, they bend in such a way that they produce different colors. And why do they all produce different colors? Because once it transfers to the next medium, they all have different speeds. Red and violet will have different speed. So they will take different paths. That's how you have the light spreading out. Okay. So let's move on. Now Newton did an experiment to prove this prisms spreading out of white light and all that. So what he did is, first he took a prism, okay, and then he made white light pass through it, and then he saw that it split up into red, okay, it split up into red and violet, and all the colors are there in between. I am just putting red and violet because that's the first one and the last one. It split up, and then he kept another prism inverted. So these 7 colors, when it passed through the second prism, it came out white. So if you have 2 prisms, from the first prism white light goes, it spreads into 7 colors. These 7 colors go to the next prism, there it combines back into white light. So this was Newton's experiment of white light, okay. He had 2 prisms. Now why does this bending happen? Because there is refraction. Now formation of a rainbow. So what happens in a rainbow? So these are all very important questions. One of this will definitely come. What happens in a rainbow? From sun white light comes, okay. This white light comes and hits water droplets that are there abundantly in the atmosphere. So sunlight comes, hits the water droplets. Inside the water drop, it disperses into different colors, and they hit all those different colors, hit the bottom of the water droplet. From there they are reflected again and they are reflected out. But when they come out, they are there in different colors. So white light came in, it hit the bottom, again it hit and then it reflected. So basically it is being reflected twice. It's reflected here, okay, it's refracted twice, here and here it's refracted, here it's reflected. So it comes in from air to the water bubble, then air to the water, it's bent, it hits here, it's reflected, it bends again back to air. Okay, so this is how a rainbow is formed. Next is some explanations for some reactions. First is the twinkling of stars. So stars are very far away, okay. So when they are very far and when light passes through different layers to reach your eyes, they bend a lot, okay. So since the star's position is very far, the amount of light reaches us, the brightness always keeps changing. That's why it appears to be twinkling. But then why do planets not twinkle? That's because planets are not that far compared to stars. So they're not that far that all the light from the planets reach our eye at the same time. So we don't feel like it's blinking. Now advanced sunrise and delayed sunset, that is because of this process. So imagine you are standing here, okay. So the sun is here. So the moment sun reaches, okay, this is for sunset. So imagine sun is here. So you are able to see this, okay. But even after the sun reaches here, so for sunrise, what happens is, once the sun reaches here, what happens? This ray is actually bending and reaching your eyes. So you see the sun even though it hasn't actually risen, because the light ray bends to reach your eyes. And then once it reaches this point, you see it again. So for this whole distance, you see it at the same place. That's because of the refraction. Now visible light has different wavelengths, as I said. Red has the longest, blue has the shortest. So one thing I want you to know is short wavelengths travel more, okay. So if I have a torch here and I have blue and red, and if you are standing at one position and another person is standing behind you, so the person in front will be able to see blue more, because blue travels a shorter distance, but the person at the back, long back, he might not be able to see blue, because by the time blue reaches him, it will all fade away. So that explains several phenomena like why the sky is blue, okay. So blue light, since it has a lower wavelength, a shorter wavelength, it can scatter more. That is why during day the sky appears blue, because blue light has shorter wavelength, it can scatter more, okay. Yeah. Now Tyndall effect. So Tyndall effect is when light is scattered by small particles. So there are so many particles, okay. So light is scattered by so many tiny particles. These particles are like dust, smoke, all of those tiny particles. And what happens is, depending on the size of the particle, the wave that comes out of it is mattered. So for example, for small particles, blue light is scattered because it's a shorter wavelength, shorter particle. For medium particles, red light. For very big particles, it is white light. That is why sometimes, because of Tyndall effect, everything appears white, because the particles that refract it is very big, okay. Delayed sunset is mainly caused by atmospheric refraction. Yes, you can write that also. Yes, Jayuri, you can write that as well. Okay. Now, why astronauts see the sky black? That's because in space there is no light. Okay. There is no light to see anything. There is no refraction there. So, there is no air in space to scatter light as well. Even though sun has light, but how do you see light? Because light falls on particles and it is scattered to your eye. But in space there is no particle. So, even if the sunlight has no particles to scatter the light. That is why astronauts see the sky black. Now, why does sun look red at sunrise and sunset? So, it's basically because near the horizon sunlight passes through more air. So, when it passes through more air, blue light is scattered away, it's lost. So, the only thing that reaches you is red. This is the same why red traffic signals are always red. That's because red light will definitely reach your eye. Blue might be scattered away, you might not be able to see it, but red will definitely reach your eye from very far distances. See, from close everything is the same, but when you go very far, blue is scattered away, it will not reach you, but then red can reach you. Okay. Next, okay, so this is the end of chapter, which one? Light. Now, we will quickly look at the chapter magnetic effects of electric current. So, in this chapter, the first formula that you need to know is, not the formula, the first concept that you need to know is, any wire that has current, it has electricity, it also has a magnetic field around it. Okay, that is what we are going to use here. First, we will learn something about magnets. Okay, so a magnet is something that has two poles. Okay, now even if I cut the magnet, it will still have two poles. If I cut it again, it will still have two poles. Magnets always will have two poles, and the magnets have field lines. These field lines always start from the north pole and they go into the south pole. And the number of field lines will determine the intensity of magnetic field around it. So, if the field lines are very close, it's very strong. Now, as you move away from the field magnet, the field line, the spacing between the field lines will be more because the effect of the magnet is less there. Okay, so a magnet has two poles, like poles repel, unlike poles attract. Okay, now if you suspend a magnet freely, it will always align with the Earth's magnetic field. Now, this is how initially people did not know the structure of magnetic field. So, what they did is they put compasses. So, they took a magnet and they kept a compass. Every time the compass pointed towards the north. So, at the north they kept the next compass. So, here also it points this way. Here you keep the next compass. And if you keep compasses like that and trace out the structure, you will get the size of the shape of the magnetic field lines. Now, some main points, same properties very important for magnetic field are, the magnetic fields always start from the north pole, they move to the south pole. They are always closed. Did you see any magnetic field line that's breaking in between? They are always closed and form loops. Okay, they are always closed and they form continuous curves. And if this is a magnetic field line, another one cannot go this way. It can only pass like this. No two magnetic field lines can intersect. And inside a magnetic field lines, it always moves from the south to the north. And the strength is determined by the number of field lines. For example, if you have field lines, this is stronger. As the space changes, it's becoming weaker. Okay. Next is the right hand thumb rule. Okay. So, right hand thumb rule, you can all take your right hand. So, if you take your right hand, the thumb represents the direction of current and your fingers represent direction of magnetic field. So, if I do this, if the current is in the upward direction, magnetic field lines are in this direction. If current is downwards, magnetic field lines are in this direction. So, you can see here current is downwards. So, let us do that. So, magnetic field lines are in this direction, which is this direction. Okay. So, that is right hand thumb rule. Right hand thumb rule helps us identify the direction of magnetic field if the current is given. Now, magnetic field due to a straight current carrying conductor. So, what I have is, I have a current wire, it is connected to a circuit with a resistance an ammeter, okay, it has a battery, basic circuit. Now, we learned through wires there is current, but here we will see that through wires there is magnetic field also. So, here I have taken a piece of paper and I have put some iron fillings on it, some iron powder on it, okay. So, once I switch on the circuit, current starts flowing through the wire. When current starts flowing through the wire, it naturally produces a magnetic field, and you can see the iron dust that you put here, it will form rings. What do rings represent? Magnetic field lines. So, this is a proof that a current carrying wire produces magnetic fields. Okay. So, the current carrying wire produces magnetic fields. This is the experiment. Okay, let's move on. Next is the current carrying magnetic field due to current through a circular loop. So, let's look at every case. First, we will look at this point. So, in this point, the direction of current is up. Yeah. So, the direction of current is up. So, how should the magnetic field lines be? It should be like this. So, here also the field line should be curling. So, it should be like this. Now, if you look at the center, the magnetic field is always straight. So, the magnetic okay. So, magnetic field is always forming in loops when it's having current in one particular direction, but at the center magnetic field is always straight. Okay, this is very important. So, magnetic field, now how can you increase the magnetic field? There are two ways. The first one, increase the amount of current flowing through the wire, or you can increase the number of turns on the coil. Next is to a solenoid. So many people have been asking me what a solenoid is. So, we learned that a straight current carrying wire has a magnetic field around it. Now, what I will do is I will take the straight wire, I will make it into a coil like this. I will just make it into a coil. So, now this whole coil will have a magnetic field around it, just like the straight wire has. Even if I change the shape, it will still have a magnetic field. So, this whole coil will now have a magnetic field around it. This is called a solenoid. Now, how can I make a solenoid an electromagnet? Inside this coil here, I will place a material, a conductor like a soft iron. Okay, that's how I can make a solenoid an electromagnet. Solenoid is basically a current carrying wire made into a coil. If I place an iron core in between, it becomes an electromagnet. Okay, so inside the solenoid I have field lines. It's just like a bar magnet. You saw, right, from the north to south, field lines moving. So, this is just like the bar magnet. Now, to increase the strength of current on a solenoid, you can again increase the number of turns. You can also increase the current, and you can make it an electromagnet by placing an iron core in the center. Next is the force on a current carrying conductor in a magnetic field. So, imagine you have two magnets. You have a north pole, south pole, this is a magnet, and you have a current carrying wire. So, current carrying wire also has a magnetic field around it. Okay. So, you have two magnets, you have a current carrying wire. So, you have two magnetic fields here. So, when two magnetic fields come in contact, they interfere and they produce a force. So, that force is determined by this rule. It is this rule, it is the Fleming's rule. So, what you do is, you take your left hand and this thumb represents the direction in which the wire moves. Conductor placed in a magnetic field, a coil of you don't have to insulate the copper wire for a coil. Rolex Gaming, what is your question? I just saw this. What is magnification? What is magnification of what? Magnification is basically the ratio between the image and the object's size, height. Okay. So here this force is how this wire will move because of the two magnetic fields. Now this B is basically the two magnetic field. The magnetic field because of the magnets, it's always from the north to south. So here my B will be like this, north to south. I is the direction of current. So what do? I will find out F. What are the things that I know? I know B is from north to south. I know I is which way? Down. So my wire will move like this. Okay, if I is down, B is north to south, I is down, then this is pointing this way. So that means force is towards U. If it's the other way around, it will be opposite. Again, north to south, let's say current is like this. So force will be in the other way. Okay. Now domestic circuits. So we know earth wire, live wire, neutral wire. So if every time you have a plug, there will be three wires: the earth wire, the live wire and the neutral wire. So the earth wire is a wire that is grounded. It's given to the earth for any extra charges to go. Okay, then that's fine for solenoid. I mean, what I was saying is it's not necessarily insulated. Okay, it's not that your answer is wrong, Gaurish. Okay, so earth wire is passing through the earth, and then the live wire is through which the main power, all of the voltage passes. It passes through the electricity board, which is the fuse. Then there is an electric meter. Then there is a box, which is the distribution box. Okay, and then it goes to the plug points. This is the socket. So to the socket, one point is the earth wire, the other is the live wire, which is the main, and then you have neutral wire. So let's look at all of this. So inside the plug you have three wires. So one is the earth, one is live, one is neutral. So usually the live wire is always red. So that is through the live wire is where most of the electricity pass through. Not most, all. Now neutral wire is the black one. It is basically at zero. So if live has full potential, this will have zero potential. Earth is basically with green, it's just for protection. So if there is a leakage in the live, all the voltage will go to the earth and it will be grounded. It is for protection. Now domestic circuits are of two types. A circuit which has 15 amps rating. This is mainly for appliances with very high power ratings such as geysers, air coolers and all. But if you have 5 amps rating, you should use it only for fans, bulbs and all. This is less. Okay, these are the two different kinds of domestic circuits. Now safety devices. See, this is how the earth wire is earthed. It's given to the ground. So any leakage in the main wire, it will be sent to the earth wire and it will be grounded. Okay. Now, yeah, earth wire is an important safety device in domestic circuits because it prevents electric shocks. If there is a small cut or leakage in the live wire, the current is sent directly to the ground. That is why it is mainly used for, okay, it is used for protection. Now, faults in domestic circuits. The first thing is short circuit. Short circuit is when, see, live wire has full potential, neutral wire has zero, but live and neutral they are insulated, but if they come in contact by some fault or some damage, that is when you have a short circuit. Everything suddenly stops working because the two wires have come in contact, which is dangerous. That is when there is short circuit. Now, overloading is when excess voltage flows. So if the wire has a capacity of 230 volts, if 250 comes, that's overloaded. That is not what the wire can take. It is beyond its maximum capacity. So that is overloading. Now, overloading can occur due to many reasons. The first one is direct contact between live and neutral. So as I mentioned, when the short circuiting, overloading can also happen. Another is an increase in the supply voltage from the main power supply itself. If the voltage is high, that's when there is another overloading happening. And then connecting too many appliances to a single socket. So to a single socket, if you connect a fridge, an AC, a refrigerator, a washing machine, so many things, it will all together burn out because you are giving more load to it. Okay. What is solenoid? As I said, a current carrying wire, it is made into a loop. You are making it into a coil and you are allowing current to pass through it. So what happens? A current carrying wire has magnetic field. So when it is made into a loop, it also has a magnetic field around it. So this is similar to a bar magnet. That is a solenoid. Both overloading and short circuiting are not same, but overloading can produce short circuit. Okay. So these are the main important topics that you need to know in your 10th grade. Okay. So we have covered three main important topics. We have covered electricity, we have covered light, and we have covered magnetism. So these are the three main things that you need to know. So I will share this with you. Okay, you have to go through all of this. There are some questions also. These are all the basic concepts that you need to know. Okay. So if you know this much, I can guarantee you can do quite well in your exam. Alright. So I hope this was a helpful session. This much is what we will discuss today. If there is anything more, we will discuss in the next coming classes. I don't know if there will be another class, but still. Ma'am, short circuiting and overloading are same. See, when there is overloading, short circuiting can happen. Short circuiting is only when live and the earth wire, neutral wire, right? Yeah, the live and neutral wire, they come in contact. That's when short circuiting happens. Overloading is due to many reasons. Overloading is due to more voltage coming in, it's due to short circuiting, it's also due to connecting too many appliances. So it's because of so many things. But short circuiting is only because of one thing, because the live wire and this one comes in contact. Okay. Any other doubts? If there's anything, quickly ask, because we're winding up the session. That's all for today. So these are all important topics. Okay. So students, I want to say all the best to you for your exam. Do well, sleep well, study well, go do well. All the very best. Okay. If you like the class, please go subscribe, please like, okay, and give me some comments so I know how your preparations are going and how my class was and all that. Okay. We need your support to keep doing this. Okay. So only if you support, we will keep doing this, because the channel has to go on. So all of you, please go hit that like button and give us a quick like, and you can get full marks if you, I won't say full marks, but you can get good marks if you look at this, because you don't know what questions coming. So I just don't want to give you false hope. What else? What is the use of earth wire? Earth wire is basically a wire that if there's any short circuiting or something, this voltage, it has to go somewhere. So you connect it to the earth. So such that it does not go anywhere else. It does not affect anything. It just goes to the earth. It's for protection. Okay. Anything else? Quickly you can ask. Otherwise we'll show. Alloys is basically mixture of metals. When two or more metals are mixed together, I get an alloy. An alloy will have a better property compared to the individual elements. It will have lower resistivity, which is a good thing. Okay. Okay, thank you. Please, can you all put this in the comments as well? Can you let me know how my class was? Not in the live chat, but in the comments as well, so I can keep doing this. So thank you all. I love you all, and have fun. Do your exam well. Okay, bye-bye. If you have any doubts or something, you can put it in the comments as well. Okay, I will stop streaming. Bye, students.